Hello, dear friends, and welcome. I'm so happy to have you here. As we begin, I'd love it if you could share in the comments where you're joining from and the time of day it is for you right now. It's always wonderful to witness people tuning in from across the world. Thank you as well to those who have already subscribed and shared their support by liking the videos. It helps more than you know. And please don't hesitate to leave your ideas or requests for future videos. Let's get started. Chapter 1. Understanding Aurora Borealis Basics. The Aurora Borealis, often described as one of nature's most breathtaking spectacles, invites wonder and curiosity. This phenomenon, also known as the Northern Lights, paints the night sky with vibrant hues of green, pink, violet, and sometimes even red. Imagine standing under a canopy of stars, the air crisp and cool as waves of color ripple across the horizon. It is a moment that leaves an indelible mark on the soul, a reminder of the beauty and mystery of our universe. Historically, the Aurora Borealis has captivated human imagination and sparked numerous interpretations across cultures. Indigenous peoples in the Arctic regions often viewed these lights as spiritual messages or the dances of ancestral spirits. The Sami people of Scandinavia, for instance, believed that the lights were the souls of their ancestors. They would celebrate these celestial displays, telling stories of how the lights reflected the emotions and actions of their forebears. In contrast, Viking lore held that the Northern Lights were the reflections of the Valkyries, warrior maidens guiding fallen heroes to Valhalla. Each culture carries its own rich tapestry of narratives, enriching our understanding of this natural wonder. The scientific explanation behind the Aurora Borealis is equally fascinating. It arises from the interaction between the Earth's magnetic field and charged particles emitted by the sun, known as solar wind. When these particles collide with gases in our atmosphere, primarily oxygen and nitrogen, they produce stunning light displays. Picture this. During periods of high solar activity, the sun releases a surge of particles that travel through space, some eventually reaching Earth. As they encounter the magnetic field, they are funneled toward the polar regions, where they ignite the atmosphere in a dazzling array of colors. You might wonder why these lights are more visible in certain locations. The answer lies in the geographical positioning of the auroral oval, which encompasses areas near the magnetic poles. The best places to witness the Northern Lights include parts of Alaska, Canada, Norway, Sweden, Finland, and even Iceland. Each of these locales offers a unique backdrop, from snow-capped mountains to vast tundras, enhancing the experience of this celestial phenomenon. Imagine standing on a frozen lake in northern Canada, the dark water reflecting the shimmering lights above, creating a perfect harmony between earth and sky. As we explore the geography of the Northern Lights, it becomes evident that timing is crucial. The best chances to see the Aurora Borealis occur during winter months when nights are long and dark. This is particularly true in places like Fairbanks, Alaska, where the clear, cold air provides an unobstructed view of the sky. The phenomenon is also often best viewed away from city lights, where the darkness amplifies the brilliance of the colors. In recent years, the accessibility of these locations has allowed more people to experience the magic of the Aurora Borealis. Tour operators now offer guided tours that not only take visitors to the best viewing spots, but also provide insights into the science and cultural significance of the lights. These experiences can foster a deeper appreciation for the natural world, blending adventure with education. In addition to the visual splendor, the Aurora Borealis has inspired various artistic expressions. Musicians, poets, and painters have sought to capture the essence of the Northern Lights, translating the ethereal experience into art. For instance, the composer Jean Sibelius found inspiration in the Finnish night sky, weaving the spirit of the auroras into his symphonies. His music echoes the feelings of awe and transcendence experienced beneath the dancing lights, inviting listeners to share in the wonder. The aurora borealis has also played a pivotal role in scientific exploration. Researchers study these lights not only for their aesthetic value, but also for what they reveal about our planet's atmosphere and magnetic field. The data collected from auroral activity helps scientists understand solar storms and their effects on satellite communications and power grids. This interplay between art and science is a testament to humanity's enduring quest for knowledge and beauty. As we reflect on the aurora borealis, it becomes clear that it is more than just a natural phenomenon. It is a bridge connecting us to our ancestors, our planet, and the cosmos. Each flicker of light carries with it centuries of stories, scientific inquiry, and cultural significance. The northern lights remind us of our shared existence on this planet and the mysteries that continue to unfold above us. Imagine yourself lying under the vast expanse of the night sky, enveloped in the cool embrace of a winter breeze, as vibrant colors swirl and dance overhead. What thoughts come to mind as you witness this celestial ballet? Perhaps you feel a sense of connection to those who have gazed at these lights long before you, contemplating their meanings and origins. The aurora borealis, with its ethereal beauty, invites us to pause, reflect, and marvel at the wonders of the universe that surround us. The geographical dance of the aurora borealis unfolds in a delicate relationship with solar activity. Scientists have learned that during periods of heightened solar activity, such as solar flares and coronal mass ejections, the auroras can extend beyond their usual confines. Imagine the thrill of witnessing the lights flickering over regions where they are seldom seen, as if the universe is sharing its secrets with those fortunate enough to be in the right place at the right time. This phenomenon is not just limited to the polar regions. On occasion, the northern lights can be glimpsed further south, painting the skies of places like northern Europe or even parts of the contiguous United States. The unpredictability of these displays adds an element of excitement, as sky watchers venture out into the night, hoping to catch a glimpse of this elusive spectacle. Consider, for a moment, how the understanding of the aurora borealis has evolved over time. Early scientific inquiries into the lights were often speculative, blending observation with myth. It was not until the 19th century that scientists began to elucidate the mechanisms behind the auroras. The pioneering work of physicist Michael Faraday and others laid the groundwork for our understanding of electromagnetism, which is crucial to comprehending this phenomenon. Faraday's curiosity and experimental spirit exemplify the essence of scientific discovery. As he once stated, "Nothing is too wonderful to be true if it be consistent with the laws of nature." Such words resonate deeply when considering the interplay of natural forces that create the auroras. The charged particles from the sun, when colliding with atoms in our atmosphere, create energy that is released as light. Oxygen produces green and red hues, while nitrogen contributes blues and purples. Each color is a story, a reflection of the atmospheric conditions at play. Imagine the complexity of these interactions, a symphony of particles and gases engaged in a cosmic performance that has fascinated humans for centuries. The aurora borealis also serves as a living laboratory for researchers examining space weather. Understanding these phenomena can provide essential insights into the sun's activity and its impact on Earth. Solar storms can disrupt satellite communications and power grids, leading to significant implications for modern society. As we become increasingly reliant on technology, the importance of studying the northern lights extends beyond the aesthetic. It becomes an essential element of safeguarding our technological infrastructure. Let us reflect on the ecological significance of the regions where the aurora borealis is visible. The tundra, with its resilient ecosystem, teems with life adapted to extreme conditions. Caribou migrate through these landscapes, following ancient routes etched into their memory. The lights above seem to whisper to these creatures, guiding them across vast expanses of snow. Imagine the tranquility of this scene, where the dance of the auroras mirrors the graceful movements of nature below. Indigenous cultures have long understood the rhythms of the earth and sky, their knowledge passed down through generations. The Inupiat people of Alaska, for example, have profound connections with the land and the celestial phenomena above. Their stories intertwine with the natural world, revealing a deep respect for the cycles of life that are reflected in the auroras. These cultural interpretations enrich our understanding and appreciation of the Northern Lights, reminding us that we are part of a larger narrative that encompasses both science and spirit. As we journey deeper into the world of the Aurora Borealis, we cannot overlook the role of modern technology in enhancing our experience. With advancements in photography and imaging, capturing the beauty of the Northern Lights has become more accessible. Enthusiasts armed with cameras venture into the wilderness, documenting the ephemeral nature of the auroras. Each photograph serves as a testament to a fleeting moment, encapsulating the awe and wonder inspired by these celestial displays. Imagine standing among a group of fellow adventurers, all eyes turned skyward, hearts racing at the first glimpse of shimmering colors. The air is filled with gasps of delight, shared laughter, and a collective sense of wonder. This human connection to the natural world, amplified by the beauty of the auroras, creates bonds that transcend language and culture. The Aurora Borealis also acts as a reminder of our shared responsibility to protect the environment. As climate change alters weather patterns and affects polar regions, the delicate balance that allows the auroras to flourish hangs in the balance. Each time we gaze upon the lights, we are reminded of the fragility of our planet and the need for stewardship. What steps can we take to ensure that future generations will witness this extraordinary phenomenon? In contemplating these questions, we cultivate a sense of mindfulness and connection to the Earth. The Aurora Borealis is not merely a visual marvel. It serves as a catalyst for thought and reflection, urging us to consider our relationship with the environment and the universe that hosts such beauty. As the chapter unfolds, let us continue to explore the many layers of the Aurora Borealis, each revealing a new facet of this captivating phenomenon. From the scientific wonders that govern its existence to the rich tapestry of cultural narratives woven around it, the Northern Lights remain an endless source of inspiration and intrigue. Each flickering glow beckons us to look up, to dream, and to ponder the mysteries that lie beyond our earthly realm. As we delve further into the captivating realm of the Aurora Borealis, we uncover the intricate relationship between this phenomenon and various atmospheric conditions. The interplay of temperature, humidity, and wind patterns contributes to the visual spectacle that enchants observers. During particularly cold nights, the clarity of the atmosphere enhances the visibility of the lights, creating a canvas on which nature paints its masterpieces. Have you ever wondered how the weather might affect your chances of witnessing the Northern Lights? Picture a calm night where the air is still, allowing for a clear view of the heavens. In contrast, gusty winds can stir up clouds, obscuring the auroras from view. The atmospheric conditions not only influence the brightness and color of the lights, but also the frequency at which they appear. In addition to the immediate weather, the seasonal cycles play a crucial role in the Aurora Borealis experience. The winter solstice, when the nights are longest, offers prime opportunities for viewing. The prolonged darkness allows stargazers ample time to catch glimpses of the ethereal displays. Imagine the stillness of a winter night, the world blanketed in snow, as you stand outside, your breath visible in the air, waiting for the first signs of the auroras to unfurl across the sky. As we consider the science behind the lights, we cannot overlook the role of geomagnetic storms. These storms, caused by disturbances in the solar wind, can intensify the auroras, transforming them into breathtaking displays of light. The auroras can sometimes surge with such vigor that they create curtains of color that sway and ripple, resembling the fabric of the night sky coming to life. The unpredictability of these storms adds an element of excitement, leaving observers in awe of nature's power and beauty. The stories of those who have witnessed the aurora borealis are filled with wonder and reverence. Many recount moments of profound connection, where the experience transcends mere observation. One adventurer described his first sighting as a spiritual awakening, the lights filling him with a sense of peace and belonging to something greater than himself. Such narratives remind us that the northern lights are not merely a visual phenomenon, but an experience that can touch the soul. The scientific community continues to be fascinated by the aurora borealis, using advanced technology to study its intricacies. Satellite missions and ground-based observations work in tandem to track solar activity and its effects on Earth's atmosphere. Through these efforts, researchers gain insights into the interaction between solar winds and the magnetic field, deepening our understanding of both auroral phenomena and the conditions necessary for their occurrence. Imagine the thrill of scientists as they monitor solar activity, eagerly anticipating the next solar flare that might light up the night sky. With each discovery, we inch closer to unraveling the mysteries of this celestial dance, piecing together a puzzle that has intrigued humanity for centuries. Moreover, the aurora borealis serves as a reminder of our planet's dynamic nature, a living testament to the forces at play in the cosmos. It inspires scientists and laypeople alike to explore the wonders of physics and astronomy, igniting curiosity and passion for the natural world. The study of these lights encourages us to look beyond our terrestrial concerns and consider our place in the universe. As we prepare to witness the northern lights, there is a unique camaraderie among those who gather in anticipation. Often, groups of friends or families venture into the wilderness together, sharing snacks and stories beneath the vastness of the night sky. The collective breath of awe when the first colors appear creates an unspoken bond among those present. How does this shared experience enrich our lives? In a world often filled with distractions, the simplicity of standing together in silence, gazing upward, fosters connections that transcend the ordinary. The aurora borealis invites us to pause and appreciate the moments of beauty that life offers, encouraging mindfulness and gratitude. As we contemplate the future of the aurora borealis, it is essential to recognize the impact of climate change on this extraordinary phenomenon. The delicate balance of our environment is shifting, altering weather patterns that may affect the visibility and frequency of the northern lights. What can we do to ensure that future generations can enjoy this celestial wonder? The answer lies in our collective responsibility to nurture and protect the planet. By fostering a deeper understanding of the intricate systems that govern our world, we can inspire action towards sustainable practices. Each glowing aurora we witness serves as a call to action, urging us to become stewards of the earth, preserving the beauty that inspires us. As we journey through this chapter, we begin to appreciate the aurora borealis not only as a remarkable natural display, but as a multifaceted phenomenon that intertwines science, culture, and human experience. It serves as a bridge between our past and future, urging us to explore the mysteries of the universe while honoring the traditions and stories that shape our understanding. In the next sections, we will further delve into the cultural narratives surrounding the northern lights, exploring how different societies have interpreted this phenomenon across time and space. Each story will enrich our appreciation of the auroras, reminding us that they are not just a spectacle, but a profound expression of humanity's connection to the cosmos. Let us continue to explore these narratives, inviting the wonder of the aurora borealis to illuminate our understanding of the world around us. Chapter 2: The Sun's Charged Particles Explained. The Sun, a blazing orb of nuclear fusion, is an unending source of energy and activity. Its surface, constantly roiling with violent eruptions, contributes significantly to the enchanting displays of the aurora borealis. As we explore this cosmic relationship, we shall uncover the nature of solar activity, the types of charged particles it emits, and the journey these particles undertake to reach our planet. When we look at the sun, we often see it as a constant presence in our sky, but it is anything but still. Solar activity manifests in various forms, including sunspots, solar flares, and coronal mass ejections. These phenomena occur due to the sun's magnetic field, which twists and turns as the sun rotates. This magnetic field can become unstable, resulting in the release of energy that leads to solar flares, intense bursts of radiation that can be millions of degrees hotter than the sun's surface. Imagine the sun as a giant cosmic furnace where magnetic forces create conditions ripe for explosive outbursts. Solar flares are often accompanied by coronal mass ejections, which are massive bursts of solar wind and magnetic fields rising above the solar corona or being released into space. These ejections can release billions of tons of plasma into the solar system, sending charged particles hurtling through the void. The sheer scale of these ejections is mind-boggling, with plasma accelerating to speeds that can reach millions of miles per hour. As we delve into the types of charged particles emitted by the sun, we find a diverse array. The primary particles include electrons, protons, and heavier ions, each carrying a unique charge and mass. Electrons are lightweight, negatively charged particles that zip through space with ease, while protons, the positively charged particles found in atomic nuclei, are significantly heavier. Heavier ions, such as helium nuclei, play a vital role in the solar wind as well. Can you picture these particles racing away from the sun, propelled by the immense energy of solar eruptions? Their journey is not just a random scattering, it is a well-orchestrated flow known as solar wind. Solar wind is a continuous stream of charged particles released from the sun's outer layer, the corona. This wind travels through the solar system, carrying with it the magnetic field lines of the sun. It is a dance of particles that connects the sun to the planets, including Earth. As solar wind approaches Earth, it interacts with our planet's magnetic field, creating a protective shield known as the magnetosphere. This shield deflects most of the charged particles away, but during periods of increased solar activity, such as during solar flares or coronal mass ejections, some particles penetrate this shield. The result is a stunning light show that we recognize as the auroras. The beauty of the auroras lies in their connection to the sun's charged particles. When these particles collide with gases in Earth's atmosphere, they transfer energy, causing the gases to glow with ethereal colors. Oxygen at different altitudes produces varying hues, a gentle green at lower elevations and brilliant red at higher altitudes. Imagine witnessing a celestial ballet of colors, each shade telling a story of its origin in the sun's charged particles. Throughout history, the sun's charged particles have fascinated scientists and explorers alike. One of the remarkable figures in this field was Pierre-Simon Laplace, who, in the late 18th century, began to theorize about solar phenomena. His work laid the foundation for understanding how the sun influences the Earth. Another notable figure Christian Birkeland, studied the auroras and proposed that they were caused by solar particles. His pioneering theories opened the door to a deeper understanding of the interactions between solar wind and Earth's magnetosphere. As we consider the journey of these charged particles, let us reflect on the vastness of space. The solar wind travels from the sun to Earth in a journey that can take anywhere from a few minutes to several days, depending on the solar storm's intensity. Imagine a vast expanse of darkness, and within that void, tiny particles race across, traversing unimaginable distances in search of connection. At times, the sun's activity increases, leading to what is known as space weather. This can have profound effects on our planet, from disrupting satellite communications to enhancing the beauty of the auroras. During periods of heightened solar activity, the auroras can be seen at lower latitudes than usual, captivating those fortunate enough to witness the displays. The interplay between the sun and Earth is a reminder of our place in the cosmos. As the sun sends its charged particles toward us, it creates a bridge between our world and the universe beyond. Each auroral display is a manifestation of this connection, an invitation to ponder the mysteries of our solar system. In this exploration of solar activity, charged particles, and their journey to Earth, we find not just scientific facts, but a deeper appreciation for the universe's intricate design. The sun, with its vibrant eruptions and graceful emissions, serves as a reminder of the beauty and complexity of our celestial environment. As we continue this journey, we will uncover even more mysteries that lie beyond the horizon, waiting to be discovered. The solar wind, an almost poetic flow of charged particles, serves as both a messenger and a harbinger of the sun's activity. As it travels through the solar system, it plays a crucial role in shaping not only the auroras, but also the broader space environment around Earth. Imagine this invisible river of energy coursing through the vast emptiness, carrying the sun's essence to every corner of our planetary neighborhood. As the solar wind approaches Earth, its dynamic interaction with the planet's magnetic field becomes a captivating spectacle of forces at play. The magnetosphere acts as a shield, an invisible barrier that protects the Earth from the brunt of these charged particles. However, during periods of intense solar activity, this shield can become temporarily overwhelmed. The result is a surge of particles that penetrate deeper into the magnetosphere, sometimes causing geomagnetic storms. These storms can unleash a cascade of effects, from dazzling auroras to disruptions in technology. The energetic particles can interfere with satellite operations, GPS systems, and even power grids on Earth. Yet, amidst these challenges lies a wonder, a reminder of the sun's powerful influence over our daily lives. Can you envision the balance between chaos and beauty as the charged particles create spectacular light displays while simultaneously demanding our technological vigilance? The solar wind is not uniform, it varies in density and speed. This variability is a reflection of the sun's activity, fluctuating with the solar cycle, which spans approximately 11 years. During solar maximum, the sun is more active, producing more sunspots and solar flares, and consequently, a stronger solar wind. Conversely, during solar minimum, the sun's surface is relatively calm and the solar wind weakens. This cyclical dance of activity shapes not only the auroras, but also the conditions for space exploration and our understanding of the universe. Throughout history, the study of solar particles has evolved dramatically. One of the pioneers in solar physics was Gustav Kirchhoff, who explored the nature of sunlight and its spectral lines. His work laid the groundwork for understanding how light interacts with matter, leading to significant advancements in our comprehension of solar emissions. His findings prompted scientists to ask deeper questions about the sun's composition and its effects on Earth. As we consider the charged particles and their journey, it is essential to appreciate the scale of the solar system. The distance from the Sun to Earth is vast, yet the solar wind traverses this expanse with remarkable speed. Picture a cosmic highway, where these particles embark on a journey that connects two celestial bodies, a journey marked by an intricate web of magnetic and gravitational forces. The solar wind does not travel in isolation. It interacts with the solar magnetic field, creating complex structures known as the heliosphere. This vast bubble, encompassing the entire solar system, defines the realm where the solar wind dominates. Imagine standing at the edge of this bubble, witnessing the interplay of solar and interstellar winds as they converge and diverge, shaping the environment in which we exist. As particles venture beyond the heliosphere, they encounter the interstellar medium, a tenuous mix of gas and dust that permeates the cosmos. This interaction can create shock waves, further influencing the dynamics of our solar system. The research into these phenomena has deepened our understanding of not only solar activity, but also the broader cosmic environment in which we live. One cannot help but marvel at the interconnectedness of all things in the universe. The Sun's charged particles serve as a reminder of our cosmic lineage, linking us to the very forces that govern our existence. Every aurora witnessed is not merely a spectacle. It is a testament to the Sun's powerful influence, a connection that resonates through time and space. As we ponder the implications of solar activity and the charged particles that influence our world, we also recognize the ongoing efforts in solar research. The advent of space missions, such as the Parker Solar Probe, has opened new frontiers in our understanding of the Sun. This mission aims to get closer to the Sun than ever before, measuring the solar wind's properties in unprecedented detail. The findings from such missions are set to enhance our comprehension of solar dynamics, potentially leading to advancements in predicting space weather. The journey of the Sun's charged particles, from their explosive origin to their enchanting display as auroras, encapsulates a narrative of beauty and complexity. Each particle carries with it a story, a glimpse into the Sun's tumultuous behavior and its effects on our planet. It invites us to reflect on our relationship with the cosmos, urging us to seek knowledge and understanding in the face of its vast mysteries. As we continue our exploration of this cosmic phenomenon, we will uncover further aspects of solar activity, delving into the mysteries that continue to unfold before our eyes. Each revelation is not merely an addition to our knowledge, but a deepening of our appreciation for the wonders of the universe, a universe that is as intricate as it is beautiful. As we observe the solar phenomena, we come to recognize how the Sun's charged particles not only reveal the dynamics of solar activity, but also influence the broader cosmic environment. The delicate balance between solar wind and Earth's magnetosphere illustrates a complex interplay that governs much of our planet's space weather. Imagine, if you will, this dance of energy and matter, where invisible forces shape the very air we breathe, the technologies we rely upon, and the stunning light displays that grace our night skies. The solar wind, a continuous flow of charged particles, carries with it the Sun's magnetic field, influencing not just Earth, but also the entire solar system. This interaction is essential for the formation of the heliosphere, a vast bubble that protects our solar system from the harsh interstellar medium. Within this protective shell, the solar wind disperses, creating a boundary where the Sun's influence fades into the void of space. As this wind travels, it creates shock waves that can produce turbulence, impacting the behavior of cosmic rays and other charged particles from beyond our solar system. This boundary, known as the heliopause, marks the transition between the solar wind and the interstellar environment. It is a frontier of scientific inquiry, where researchers seek to understand how our sun interacts with the rest of the galaxy. The work of scientists like Edward Stone, who has been instrumental in studying the Voyager spacecraft, exemplifies our quest to unravel these cosmic mysteries. His efforts have shed light on the enigmatic nature of the heliosphere, revealing how it acts as a shield against cosmic rays while also allowing the solar wind to shape our local space weather. As we consider the implications of solar wind and its interaction with the heliosphere, we cannot overlook the role of solar cycles. The sun undergoes an approximately 11-year cycle of activity, characterized by periods of increased sunspot formation and solar flares. During these solar maximum phases, the intensity of solar wind increases, leading to more frequent and vibrant auroras. Conversely, during solar minimum, the sun's surface appears quieter, and the solar wind diminishes in strength. This cyclical behavior serves as a reminder of the sun's inherent dynamism and its influence on Earth. Can you imagine tracking these cycles, feeling the ebb and flow of solar energy coursing through the fabric of our planet's atmosphere? Each peak and trough tells a story of cosmic rhythms, a chronicle of the sun's life force that resonates through space and time. The study of these cycles not only enhances our understanding of the sun's behavior, but also informs our strategies for preparing for potential space weather events that could disrupt our technology and infrastructure. Amidst this exploration, we encounter the remarkable phenomenon of solar storms, which arise from the most intense solar activity. These storms can unleash immense amounts of energy, sending waves of charged particles toward Earth at breathtaking speeds. When these particles collide with Earth's magnetic field, they can create disturbances that ripple through the magnetosphere, leading to geomagnetic storms. Such storms can have cascading effects on our technological systems, from disrupting satellite communications to causing fluctuations in power grids. Yet, within this tempest lies an extraordinary beauty. The auroras, born from these very storms, emerge as vibrant manifestations of the sun's charged particles colliding with our atmosphere. Each display is a reminder of the delicate balance between chaos and harmony in the cosmos. As the particles interact with gases like oxygen and nitrogen, they create a symphony of colors, a celestial celebration that captures our imagination. Throughout history, the allure of the auroras has drawn countless observers to their breathtaking displays, inspiring artists and scientists alike. Figures like Alfred Wegener, known for his groundbreaking work in meteorology, marveled at the connection between solar activity and weather patterns on Earth. His insights contributed to our understanding of how solar phenomena influence not just the visual spectacle of auroras, but also the climate and atmospheric conditions we experience daily. As we delve deeper into the relationship between solar activity and the charged particles that travel from the sun, we uncover the underlying science that unites this cosmic narrative. The study of these particles allows us to grasp the fundamental processes at play in our universe. It is a reminder that we are not mere observers of these phenomena, but active participants in a grand cosmic story. The solar wind and its charged particles serve as messengers from the sun, carrying information about solar activity that can enhance our understanding of space weather. By studying these particles, scientists can glean insights into the mechanisms driving solar flares and coronal mass ejections, leading to more accurate predictions of space weather events. Imagine the excitement of uncovering new truths about the sun, where each discovery deepens our connection to the cosmos. As we contemplate the beauty and complexity of the sun's charged particles, we are reminded of the intricate relationships that bind us to the universe. The auroras, those fleeting moments of color dancing across the night sky, are not just optical phenomena. They are a testament to the dynamic interplay between the sun and earth, a vibrant reminder of the forces that shape our world. In our ongoing journey through the cosmos, we will continue to explore the sun's role as a powerful force in our solar system. Each chapter of this narrative invites us to reflect on the wonders of solar activity, the charged particles that emanate from the sun, and their profound impact on our lives. The mysteries of the universe await us, beckoning us to discover the secrets that lie beyond the horizon. Chapter 3: Earth's Magnetic Field and Its Influence. The sun, with its radiant energy and powerful magnetic forces, sends forth streams of charged particles into the vastness of space. As these particles journey toward Earth, they encounter a formidable guardian, our planet's magnetic field. The interaction between these solar particles and Earth's magnetic field plays a crucial role in shaping not only the auroras, but also the very environment in which we live. Imagine standing on a serene beach, the sun gently warming your skin as you gaze at the horizon. The ocean waves roll in rhythm, and far beyond them lies the sun, casting its rays upon the earth. As those rays travel through the vacuum of space, they carry with them charged particles, electrons and protons, born from the sun's furious activity. These particles are part of the solar wind, a continuous stream that flows outward from the sun, bathing the solar system in a thin veil of energy. When these charged particles approach Earth, they encounter a complex shield known as the magnetosphere. The magnetosphere is not merely a passive barrier. It is a dynamic entity shaped by Earth's magnetic field. This field, generated by the movement of molten iron within the planet's outer core, extends far into space, forming a protective bubble around our planet. Picture a shimmering shield, glowing faintly in the background as it deflects incoming solar winds. As the solar wind approaches this magnetic field, it is met with resistance. The charged particles are diverted around the planet, creating a dance of energy that forms the magnetosphere's bow shock. This interaction can be likened to a river flowing around a large rock, the water swirling and eddying in response to the obstacle. Only a small fraction of these particles manage to penetrate this shield, and it is through this selective process that Earth's magnetosphere protects us from the harmful effects of solar radiation. The magnetosphere serves multiple critical functions. For one, it prevents most of the solar wind's charged particles from colliding with the atmosphere, which would otherwise strip away vital components like oxygen. Without this magnetic shield, life as we know it would struggle to exist. Yet, some particles do find their way through this protective barrier, particularly near the poles where the magnetic field lines converge. These particles spiral down along the magnetic field lines, entering the atmosphere at high latitudes. It is here, in this ethereal realm, that the magic of the auroras unfolds. The interaction between these high-energy particles and the gases in the atmosphere ignites a breathtaking display of light and color. This process begins when solar particles collide with atoms and molecules in the atmosphere, primarily oxygen and nitrogen. These collisions excite the atoms, raising them to higher energy states. When the atoms return to their normal state, they release energy in the form of light. The colors of the auroras are determined by the type of gas involved and the altitude of the interactions. Imagine hues of green painting the night sky, accompanied by shades of pink and violet, a breathtaking reminder of the interplay between solar energy and our atmosphere. Throughout history, many have wondered about the implications of this celestial interaction. How does the magnetosphere influence not just the auroras, but also our technological lives? The answer lies in the delicate balance of forces at play. Our magnetic field not only protects us from harmful radiation, but also plays a vital role in maintaining satellite functionality and communication systems. Without this shield, satellites would be exposed to damaging solar radiation, risking their ability to function and communicate with us. Consider the words of a renowned physicist who once said, "We are all made of stardust." This phrase serves as a reminder that the very elements that form our bodies were forged in the heart of stars. Our connection to the cosmos is profound, and the magnetosphere acts as a bridge between our terrestrial existence and the vast universe beyond. What might happen if this protective barrier were to weaken? Scientists study fluctuations in the magnetosphere, especially during solar storms, when the sun's activity peaks. These storms can significantly alter the magnetosphere's structure, leading to geomagnetic storms that can disrupt communication systems and even power grids. The consequences of such events remind us of our vulnerability and the importance of understanding these natural phenomena. As we explore deeper into this realm of science, we find remarkable individuals who have dedicated their lives to studying Earth's magnetic field. One such pioneer is a scientist who devoted decades to understanding geomagnetism. She eloquently stated, "The magnetic field is a living entity, a pulse that reflects the Earth's inner workings." Her work has illuminated the dynamic nature of the magnetosphere, revealing how it responds to solar activity in intricate ways. Imagine standing in a vast field, the sun setting in the distance, as you reflect on the invisible forces that surround you. The magnetosphere is not just a scientific concept, but a vital component of our existence, intricately woven into the fabric of life on Earth. It shapes not only the auroras that enchant our nights, but also the very air we breathe and the technology we rely upon daily. The magnetic field's influence extends beyond the immediate effects of auroras and technological safeguards. It plays a crucial role in the Earth's climate system, acting as a shield against cosmic rays that can influence cloud formation. The interaction of these cosmic rays with the atmosphere can affect weather patterns, creating a delicate balance that sustains life. This connection highlights how deeply intertwined our existence is with the forces of the universe. As we ponder the mysteries of the magnetosphere, we are reminded of its beauty and complexity. The next time you gaze into the night sky and witness the enchanting dance of the auroras, take a moment to appreciate the intricate web of interactions that brought that moment to life. From the sun's fiery surface to the protective embrace of Earth's magnetic field, every element plays a role in this grand cosmic ballet. In a world where the wonders of science often feel distant, the magnetosphere serves as a tangible reminder of our connection to the cosmos. It is a force that shapes our environment, influences our technology, and creates the breathtaking displays of light that inspire awe and curiosity. As we continue on this journey of exploration, let us remain open to the stories written in the stars and the mysteries that await us just beyond the horizon. The interplay between solar particles and our magnetosphere is not just a scientific phenomenon. It is a testament to the beauty and complexity of our universe, inviting us to ponder our place within it. As we continue to explore the interaction between Earth's magnetic field and the solar particles that approach it, we must delve deeper into the workings of the magnetosphere. This protective bubble, while it acts as a shield, is also a gateway, allowing some solar particles to enter and interact with our atmosphere. These encounters create a fascinating interplay of forces that not only illuminate the sky, but also serve as a reminder of our planet's unique position in the cosmos. Picture a serene evening as the sun dips below the horizon, casting a warm glow over the landscape. In this tranquil moment, Imagine the solar particles racing toward Earth, their journey fueled by the sun's explosive energy. A significant number of these particles are deflected by the magnetosphere, but those that manage to breach this shield create a chain reaction upon entering our atmosphere. When solar particles penetrate the magnetosphere, they find themselves amidst a rich tapestry of gases. The atmosphere is primarily composed of nitrogen and oxygen, and as the charged particles collide with these atoms, something remarkable occurs. The energy from these collisions excites the atmospheric atoms, elevating them to higher energy states. This process is akin to a gentle caress, where the energy exchanged leads to a release of light as the atoms return to their stable states. This cascade of energy not only gives rise to the magnificent auroras, but also exemplifies the delicate balance of energy within our atmosphere. Can you envision the colors that emerge from these interactions? The stunning greens of oxygen at lower altitudes, the vibrant reds and pinks from the same gas at higher elevations, and the magical purples from nitrogen? Each hue is a direct result of the type of gas involved and the energy of the incoming particles. This symphony of colors dances across the sky, a visual representation of the invisible forces at play. The auroras remind us that even in the vastness of space, intricate connections exist, weaving together the elements of our world and beyond. The magnetosphere also plays a pivotal role in safeguarding our planet from cosmic rays, high-energy particles originating from outside our solar system. These cosmic rays can have profound effects on both human health and technology. Imagine a world where the delicate balance maintained by the magnetosphere falters, exposing us to these invisible rays. The potential consequences could range from increased radiation exposure for astronauts in space to disruptions in satellite operations on Earth. The magnetosphere, therefore, is not just a passive shield. It is an active guardian, constantly reacting to the ebb and flow of solar and cosmic activity. Throughout history, scientists have worked tirelessly to decode the mysteries of the magnetosphere. Among them is a trailblazer whose passion for geomagnetism has reshaped our understanding of Earth's magnetic field. This individual once remarked, "The magnetosphere is a dance of particles, a tangible expression of the hidden rhythms of our Earth." Their research has illuminated how the magnetosphere responds to solar storms, providing insights that are crucial for predicting space weather events. As we contemplate these insights, it becomes clear that understanding the magnetosphere is vital not just for scientific curiosity, but also for practical applications. For instance, during periods of heightened solar activity, such as solar flares or coronal mass ejections, the magnetosphere can become disturbed. This disturbance can lead to geomagnetic storms, which have the potential to disrupt electrical grids and navigation systems. In such moments, the beauty of the auroras can be accompanied by the challenges posed to our technology, highlighting the dual nature of this celestial phenomenon. Imagine standing underneath the auroras, the colors shimmering above you, while contemplating the vast network of satellites orbiting the Earth. These satellites rely on the stability provided by the magnetosphere to function correctly. Without it, they would be vulnerable to the very forces that create the dazzling displays in the night sky. The interconnectedness of Earth systems is a profound reminder of how everything is affected by the invisible forces of magnetism. The magnetosphere's influence stretches beyond our immediate environment. It extends into the realm of climate science, as cosmic rays interact with the atmosphere to influence weather patterns. Some researchers suggest that fluctuations in the magnetosphere may correlate with changes in cloud formation, which can have cascading effects on climate. This connection urges us to consider how our planet's protective shield is intertwined with the broader climate system, emphasizing the delicate balance that sustains life. As we ponder these connections, we are invited to reflect on the profound intricacies of our planet and its place in the universe. The next time you witness the ethereal glow of the auroras, consider the journey of the solar particles that made that moment possible. Each flicker of light is a testament to the interplay between the sun and earth, a reminder of the protective embrace of the magnetosphere, which ensures our existence amid the cosmic wonders that surround us. The stories of those who study these phenomena continue to inspire and educate. One notable figure in the field of magnetospheric research once said, "The universe speaks in languages of light and energy, and we are but humble listeners." This sentiment encapsulates the essence of scientific inquiry, the pursuit of understanding in the face of the unknown. Through the lens of the magnetosphere, we glimpse the interconnectedness of all things, a reminder that we are part of a much grander narrative. As we delve further into the relationship between solar particles and our atmosphere, we discover that these interactions bear not only aesthetic beauty, but also practical significance. The magnetosphere's role in protecting our technological infrastructure is indispensable, yet it remains an enigma, continuously shaped by the forces of nature. The interplay between the sun and earth serves as a powerful reminder of our vulnerabilities, urging us to remain vigilant in our understanding of these cosmic forces. In this vast universe, every interaction is a note in the symphony of existence. As we continue our exploration of Earth's magnetic field and its influence, let us remain open to the wonders that await us. The auroras may captivate our hearts, but it is the science behind them that enriches our understanding of the world we inhabit and the universe that cradles us. Chapter 4: The Role of Atmospheric Gases. The Earth's atmosphere, a delicate veil surrounding our planet, is composed of a mixture of gases that play essential roles in sustaining life and influencing the phenomena we witness, such as the enchanting aurora borealis. The primary components of this atmosphere include nitrogen, oxygen, argon, carbon dioxide, and trace amounts of other gases. Imagine this blend as a protective cocoon, nurturing life while also creating a canvas upon which the sun's light can paint colors that evoke wonder. Nitrogen makes up a significant portion of the atmosphere, accounting for nearly 4/5 of it. This inert gas is crucial for life, as it is a fundamental building block of amino acids and proteins. Without nitrogen, the intricate web of life we know would unravel. Oxygen, the second most abundant gas, is the breath of life. It fuels the processes of respiration in living organisms and is instrumental in combustion reactions. Picture the harmony of these two gases working together. They create a balance that allows life to flourish under the sun's warm embrace. As sunlight filters through this mixture of gases, it is refracted and scattered, giving rise to the beautiful color variations we observe in the sky. During sunrise and sunset, the sun's light must travel through more of the atmosphere, scattering shorter wavelengths and allowing longer wavelengths to dominate. This scattering creates the warm hues of orange and red that can be so mesmerizing. In contrast, on a clear midday, when the sun is high, the blue wavelengths are scattered more, painting the sky in brilliant azure. How remarkable it is that the very air we breathe can transform the light of the sun into such a vivid display. The interaction between these gases and sunlight does not end with simple color variations. The presence of water vapor, for instance, adds another layer of complexity. Water vapor can condense to form clouds, reflecting and refracting light in myriad ways. The different types of clouds, from fluffy cumulus to wispy cirrus, each contribute to the atmosphere's visual drama. Imagine observing a sunset with clouds reflecting the fiery colors of the sun while the air cools around you. creating an ethereal moment suspended in time. As we ascend through the atmosphere, the behavior of these gases begins to change due to variations in pressure and temperature. At higher altitudes, the density of the atmosphere decreases, leading to a phenomenon known as the lapse rate. This concept refers to the rate at which temperature decreases with altitude. Picture yourself climbing a mountain. With every step higher, the air becomes thinner and the temperature drops. This gradient affects not only weather patterns, but also the way we perceive the world around us. The role of atmospheric gases at different altitudes also plays a part in the formation of the auroras we have come to admire. As charged particles from the sun interact with the gases in the upper atmosphere, primarily oxygen and nitrogen, they become excited and emit light, creating those stunning displays of color. At altitudes of around 100 kilometers, the interaction is particularly vivid, leading to the greens and reds of the auroras. Can you envision the breathtaking sight of these colors dancing across the night sky, each hue resulting from the complex interplay of gases in the atmosphere? Throughout history, many scientists have dedicated their lives to understanding these atmospheric phenomena. One such remarkable figure is Robert Hooke, an English scientist from the 17th century. He made significant contributions to the study of gases and their properties, laying foundational work for future explorations into atmospheric science. Hooke famously stated, "The air is not a simple thing, but a complex mixture." His insight highlights the intricate nature of our atmosphere, a notion that resonates with the beauty we observe in the auroras. Another notable individual is John Dalton, who, in the early 19th century, introduced the atomic theory of gases. Dalton's work paved the way for a deeper understanding of how gases interact under varying conditions. As we ponder his legacy, we can reflect on the complexity of the air around us and how it shapes our world. The behavior of gases also becomes more fascinating when we consider the effects of altitude on atmospheric pressure. As one rises above the surface, the weight of the air above diminishes, causing pressure to decrease. This drop in pressure influences not only physical processes, but also the way light travels through the atmosphere. Imagine the clarity of the sky at high altitudes, where the air is thin and the colors appear more vibrant, almost as if the world below is a painting viewed from afar. In addition to pressure, temperature plays a crucial role in how gases behave. The temperature gradient can lead to the formation of layers in the atmosphere, such as the troposphere, stratosphere, and mesosphere. Each of these layers has its own unique characteristics and influences weather patterns and climatic conditions. The troposphere, where we reside, is where most weather occurs, while the stratosphere contains the ozone layer, which protects life on Earth by absorbing harmful ultraviolet radiation. One may wonder how these layers contribute to the stunning visuals of the auroras. The stratosphere, while generally stable, is influenced by the interactions of solar winds and magnetic fields. When charged particles collide with the gases in this layer, they create a mesmerizing light show that can be seen from the ground, especially in polar regions. How amazing it is to think that the very gases that support life are also responsible for some of nature's most breathtaking displays. As we consider the vastness of the atmosphere, we cannot ignore the role of trace gases. Although they exist in minuscule amounts, gases such as carbon dioxide and methane significantly influence climate and weather systems. These gases contribute to the greenhouse effect, which warms the Earth and helps sustain life. However, their increased concentrations due to human activity have led to alarming changes in our climate. Reflecting on this, one might ponder our responsibility to care for the delicate balance of our atmosphere, which sustains not just us, but countless other forms of life. With the knowledge of the intricate workings of atmospheric gases, we can appreciate the beauty and complexity of the world around us. From the vivid colors of the auroras to the breathtaking hues of the sunrise, these natural phenomena remind us of the interconnectedness of life, light, and the air we breathe. As we continue to explore the wonders of our atmosphere, let us remain in awe of the delicate balance that sustains life and fuels our curiosity about the universe. As we rise higher into the atmosphere, the interplay of gases becomes not just a backdrop to our earthly experiences, but a dynamic participant in the drama of our planet's weather and climate. Imagine a tapestry woven from threads of oxygen and nitrogen, where each strand contributes to the climate patterns that dictate our seasons and ecosystems. The delicate balance of gases in the atmosphere not only influences temperature and pressure, but also plays a pivotal role in the formation of clouds and precipitation. Clouds, those soft, ethereal formations drifting across the sky, are composed primarily of tiny water droplets or ice crystals. These droplets form through a process called condensation, where water vapor cools and transitions from a gas to a liquid state. This process is influenced by temperature and pressure, creating what we often refer to as weather. The varying densities of gases at different altitudes can lead to fascinating weather phenomena. For instance, at higher altitudes where the air is thinner, the temperature can drop significantly, leading to a different type of cloud formation compared to those found at sea level. Picture a cumulonimbus cloud, towering and billowing, its top reaching far into the colder regions of the atmosphere, creating a dramatic display that signals thunderstorms. The interaction between these clouds and atmospheric gases can result in lightning, a stunning display of nature's power, illuminating the sky with electric brilliance. The behavior of gases also plays a crucial role in the phenomenon of wind. As the sun heats the Earth's surface, the warm air rises, creating areas of low pressure. Cooler, denser air then flows in to fill this void, resulting in wind. This movement of air is not merely a gentle breeze. It can manifest as powerful gusts that shape landscapes, transport seeds, and even generate ocean currents. Consider a field of wildflowers swaying in the wind, each blossom dancing to the rhythm of the atmosphere's flow, a beautiful reminder of nature's interconnectedness. As we contemplate the altitude's influence on gas behavior, we come to understand how the atmosphere serves as a protective shield against harmful solar radiation. The ozone layer, situated within the stratosphere, is composed of ozone molecules that absorb and scatter ultraviolet radiation from the sun. This layer is crucial for life on Earth, as excessive UV radiation can lead to skin cancer and other detrimental health effects. Think of the ozone layer as a guardian, filtering out the sun's harmful rays while allowing the warmth and light necessary for life to thrive. Amidst this complexity, the role of trace gases becomes increasingly significant. Carbon dioxide and methane, although present in minuscule amounts compared to the primary gases, exert a powerful influence on global temperatures. These gases trap heat in the atmosphere, creating a natural greenhouse effect that warms the planet. This phenomenon is essential for life. Without it, Earth would be a frozen world, inhospitable to the myriad forms of life we cherish. However, as human activities contribute to an increase in these gases, the delicate equilibrium of our atmosphere is threatened, raising questions about our relationship with the environment. In the context of atmospheric research, one cannot overlook the contributions of scientists such as James Lovelock, who proposed the Gaia theory, suggesting that the Earth functions as a self-regulating entity. Lovelock's perspective invites us to view the planet as an interconnected system where gases, life, and climate are inextricably linked. His assertion that the Earth is a living entity prompts us to reflect on our role within this living system, urging us to consider the impact of our actions on the atmospheric balance. The journey through the atmosphere is not just a scientific exploration. It is also a journey of imagination. As we think about the gases that envelop us, can we visualize the invisible currents that carry weather patterns across continents, or the soft whispers of air that nurture the growth of plants? Can we appreciate the intricate chemistry that unfolds in the atmosphere, where sunlight meets the elements, resulting in a spectrum of colors, weather events, and life itself? This exploration invites a sense of wonder, as we acknowledge that the air we breathe, filled with nitrogen, oxygen, and a host of trace gases, is not just a mixture but a vital component of our existence. It shapes our climate, influences our weather, and even touches our emotions. As we stand beneath the vast expanse of the sky, let us take a moment to breathe deeply, feeling the air fill our lungs. Imagine each breath as a connection to the intricate web of life that thrives in the delicate balance of atmospheric gases. With every inhalation, we draw in the essence of our planet, and with every exhalation, we release a part of ourselves back into this great cycle. As we continue to explore the role of atmospheric gases, we will uncover more about how these elements interact with one another, leading to phenomena that not only affect our planet, but also inspire awe and curiosity in the human spirit. The atmosphere is indeed a grand stage, where the interplay of gases tells a story as old as time, a story that continues to unfold with each passing moment. Chapter 5: Color Variations in the Aurora Borealis. The aurora borealis is a breathtaking phenomenon that graces the night sky with an array of colors, each hue telling a unique story of the interactions taking place between solar particles, Earth's atmosphere, and its magnetic field. Among the most striking colors are green, red, blue, and purple, each emerging from distinct processes involving atmospheric gases and the altitude at which these interactions occur. Green, the most commonly observed color of the auroras, arises primarily from the excitation of oxygen molecules at lower altitudes, typically around 20 to 100 kilometers above the Earth's surface. When charged particles collide with these oxygen molecules, they transfer energy, causing the oxygen to emit a beautiful green light. This vivid display can often be seen shimmering across the sky, a reminder of the intricate dance of energy and matter. Imagine standing beneath the waves of green, feeling as if you are part of a living canvas painted by the universe itself. Red colors, although less frequent, are a spectacular sight. They occur at higher altitudes, generally above 100 kilometers. The red glow emerges from oxygen molecules as well, but under different conditions that require a greater amount of energy. The particles must collide with oxygen at these altitudes, where the atmospheric pressure is far lower. The result is a striking crimson, hue that can appear as a band or patch amid the green, creating a captivating contrast. How remarkable it is to think that this vibrant red is a product of such high-energy interactions, a cosmic reminder of the power of our sun. Blue and purple hues, often seen in the auroras, originate from nitrogen molecules. When high-energy particles collide with nitrogen at lower altitudes, they can emit a blue light. Additionally, the interaction of these particles with nitrogen at even higher altitudes can produce a rich purple shade. This interplay of colors creates a spectrum that can paint the sky in a mesmerizing display, shifting and swirling in response to changes in the solar wind and atmospheric conditions. Have you ever paused to consider how these colors meld, creating a fleeting masterpiece that captivates the heart? Altitude plays a critical role in how we perceive these colors. The higher we go, the thinner the atmosphere becomes, and this thinness affects the types of light that can be emitted. At altitudes above 100 kilometers, the density of the atmosphere decreases and the interactions change. The charged particles can still collide with various gases, but the energy dynamics shift, leading to different visual outcomes. Picture the atmosphere as a gradient, where the colors shift and blend as you ascend, each layer revealing a new aspect of the aurora's beauty. The intensity and brightness of the colors we perceive during an aurora are influenced by several factors. One key element is the number of charged particles reaching the atmosphere. When solar activity is heightened, such as during solar flares or coronal mass ejections, a larger number of particles stream towards Earth. This influx increases the likelihood of collisions with atmospheric gases, resulting in more vibrant displays. Imagine a canvas being painted with more strokes, the colors becoming increasingly vivid with each addition of energetic particles. Moreover, the local atmospheric conditions also play a crucial role. Humidity, for instance, can affect how we perceive the brightness of the aurora. In drier conditions, the colors may appear more vivid, while increased moisture can diffuse the light, softening the colors and making them seem less intense. It's fascinating to think that something as simple as moisture in the air can alter the experience of witnessing this natural wonder. The interplay of altitude, atmospheric composition, and solar activity culminates in an auroral display that is both dynamic and ephemeral. As we gaze upon these shifting colors, we are reminded of the delicate balance of forces that create such beauty. The northern lights are not just a visual spectacle, but a manifestation of the underlying science that governs our universe. Renowned physicist Albert Einstein once remarked, "The most beautiful experience we can have is the mysterious." Indeed, the aurora embodies this mystery, leaving us in awe of the cosmic forces at play. As we continue to explore the depths of this phenomenon, it becomes clear that the auroras are not merely a subject of scientific inquiry, but also a source of inspiration and wonder. They invite us to look up, to dream, and to ponder the vastness of our universe. The colors of the aurora borealis are a reminder that even in our ever-changing world, beauty persists, weaving itself into the fabric of our experience. The colors of the aurora borealis are not only a feast for the eyes, but also a fascinating interplay of chemistry and physics. Each hue is a result of specific wavelengths of light being emitted by different gases when energized. For instance, the deep greens that often dominate the auroral displays are primarily due to the emission from oxygen molecules at lower altitudes, while the purples and blues are birthed from nitrogen interactions at varying heights. This symphony of colors is orchestrated by the conditions present in the atmosphere, weaving together elements of our environment and the cosmos. Consider how the atmosphere acts as a filter, shaping our perception of these vivid displays. As the charged particles collide with gases, they excite the atoms, prompting them to release energy in the form of light. The specific colors we see are determined by the energy levels of these excited states. Higher energy collisions yield shorter wavelengths of light, producing the vivid blue and purple shades we sometimes see. This delicate balance of energy is crucial in crafting the aurora's palette. Altitude plays an instrumental role in this process as well. At greater heights, where the atmosphere thins, the interactions between solar particles and atmospheric gases become less frequent yet more energetic. This is why we often see red auroras at altitudes above 100 kilometers. The energy is sufficient to excite oxygen molecules in conditions where the density of the atmosphere is considerably lower. Imagine standing at the edge of a precipice, looking down at the world below, where the air is rarefied and the energies unleashed are not just powerful but transcendent. The variations in color intensity are remarkable, influenced not only by altitude but also by the density of the atmosphere and the amount of solar activity. During periods of heightened solar activity, such as during a solar storm, the influx of charged particles can create an astonishing spectacle. The skies can ignite with intensity, as if the universe itself is igniting a firework display of color. It is during these moments that the auroras can appear brighter and more vibrant than on a typical night. Renowned physicist and Nobel laureate Maria Goeppert-Mayer once said, "If I can see the universe and its wonders, I can face anything." The auroras embody this sentiment, encapsulating the awe we feel when confronted with the beauty and complexity of the universe. Imagine the thrill of witnessing a vivid display of lights, knowing that the vibrant colors you see are the result of cosmic forces at play. Moreover, the influence of local atmospheric conditions cannot be understated. Clear, dry nights often yield the most brilliant displays, as there are fewer particles to scatter the light. Conversely, humid nights may dull the colors, wrapping the aurora in a soft, ethereal glow. This subtle interplay of environmental factors can turn a spectacular show into a more subdued experience. Have you ever felt the difference in the air before a storm, as if the universe holds its breath in anticipation? As we delve into the science behind brightness and intensity, it is essential to consider how the human eye perceives these colors. The rods and cones in our eyes respond differently to various wavelengths of light, which means that some colors may appear more vibrant to us than others. For instance, our eyes are particularly sensitive to greens, which is why the central hue of the aurora often dominates our experience. This phenomenon is a beautiful reminder that our perception of the universe is as much about the biology of our senses as it is about the physics of light. In the grand ballet of the auroras, color variations are not merely aesthetic, but are imbued with meaning. They tell a story of energy, atmosphere, and the unseen forces that shape our world. The shifts in color and intensity reflect the dynamics of solar winds and Earth's magnetic field, painting a narrative across the night sky that has inspired countless generations. In that mesmerizing moment when the lights dance overhead, we connect with something greater than ourselves. We become part of a cosmic cycle, a reminder of our place in the universe. The colors of the Aurora Borealis invite us to ponder the intricate relationships that bind us to the cosmos, urging us to reflect on the beauty that emerges from complexity. How often do we take the time to appreciate the intricate workings that allow us to witness such wonders? As we continue to explore the depths of the auroras, it becomes clear that these vibrant displays are a testament to the beauty of scientific inquiry. Each color, each flicker of light is a chapter in the ongoing narrative of our understanding of the universe. The aurora serves as a bridge between science and art, a reminder that the mysteries of the cosmos can be both beautiful and enlightening. As the night unfolds, the colors of the Aurora Borealis remind us that every moment is alive with possibility, inviting us to dream and wonder under the vast, starry sky. The interplay between altitude and atmospheric composition shapes not only the colors we see, but also their intensity and brightness. At varying heights, the atmosphere's density affects how charged particles interact with the gases present. Imagine ascending through layers of air, where each stratum offers a different canvas for the auroras to manifest their brilliance. As we venture higher, the diminishing pressure allows for a unique set of reactions. The lower density means that particles can travel further before colliding with atmospheric gases. This results in a more energetic exchange, particularly at altitudes where red hues emerge. The oxygen molecules, when struck by high-energy particles under these conditions, can release energy that manifests as the rarer red auroral glow. This phenomenon illustrates a captivating aspect of the auroras, their ephemeral nature. The colors may shift within moments, influenced by the solar wind's intensity and the Earth's magnetic field's fluctuations. Each display is a fleeting moment in time, a reminder of the constant change that defines our universe. Have you ever experienced the thrill of watching something beautiful that is here one moment and gone the next? The color intensity can also be influenced by solar cycles. During peak solar activity, the influx of particles is more robust, leading to more vibrant displays. The solar cycle, which spans approximately 11 years, dictates the ebbs and flows of solar flares and coronal mass ejections. When the sun enters a period of increased activity, the chances of seeing a dramatic aurora increase exponentially. Picture a night sky filled with a symphony of colors, a dazzling reminder that the universe is alive and ever-changing. Moreover, the brightness of the auroras can be accentuated by the surrounding environmental conditions. On exceptionally clear nights, when the air is crisp and devoid of light pollution, the colors appear more vivid, as if they are celebrating their freedom from the constraints of the atmosphere. In contrast, the presence of clouds or humidity can create a muted experience, wrapping the aurora in a soft veil that enhances its ethereal quality but lessens its vibrancy. This delicate balance of elements can create an atmosphere of calm, inviting contemplation as one gazes upon the luminous sky. The science of color perception also plays a role in how we experience the auroras. Our eyes are tuned to recognize certain wavelengths more acutely, which can amplify our experience of specific colors. The human eye is particularly sensitive to green light, making the dominant hues of the aurora more striking. As we engage with these colors, we find ourselves not just observers, but participants in a cosmic dance of light and energy. The contributions of scientists and explorers who have dedicated their lives to understanding this phenomenon cannot be overlooked. People like Christian Birkeland, a Norwegian physicist, tirelessly studied the auroras in the early 20th century, proposing that they were not just random occurrences, but rather a direct consequence of the sun's activity interacting with Earth's magnetic field. His pioneering work laid the foundation for our modern understanding of the auroras, and his passion for discovery continues to inspire those who look to the skies with wonder. As we contemplate the myriad colors of the aurora borealis, we are reminded of the intricate relationships that exist within our atmosphere. The vibrant colors that stretch across the heavens are not merely aesthetic. They are a testament to the forces that govern our world. The mysteries of the auroras beckon us to engage with both the science and the beauty of the universe, inviting us to appreciate the delicate balance that allows these celestial displays to unfold. Witnessing the aurora borealis is an invitation to embrace the unknown, to find solace in the dance of light and energy that occurs overhead. As the colors shift and swirl, they remind us of the beauty that exists in the interplay of science and nature. Each moment spent under the shimmering lights is a moment spent in awe of the universe's capacity for wonder, encouraging us to dream and reflect beneath the vast, starlit sky. Chapter 6: The Science of Light Emission. The atmosphere, an intricate layer enveloping our planet, serves as a canvas for the mesmerizing displays of light we associate with the aurora borealis. At the heart of these displays lies the phenomenon of photonic emissions. When charged particles from the sun collide with the gases in the atmosphere, they excite those gases, causing them to emit light. This interaction is not merely a chance occurrence. It is a beautifully orchestrated dance of energy and matter, resulting in the breathtaking colors that ripple across the night sky. Imagine standing beneath a brilliant aurora, witnessing how the green hues brighten the darkness. This vivid emerald glow is primarily produced by oxygen molecules at lower altitudes, where their excited state releases photons of light. However, the relationship between energy levels and emitted colors is more profound than it seems. The energy imparted to the oxygen atoms during these collisions determines the color emitted. Higher energy collisions can generate red light, while lower energy interactions yield the vibrant green. The variety of colors we observe is a direct reflection of the energy spectrum of the incoming solar particles. This connection between energy and color is a fascinating aspect of quantum physics. Each element emits light at specific wavelengths when energized, creating a unique spectral fingerprint. This principle is known as atomic emission, and it is the foundation for spectroscopy. Spectroscopy, a powerful analytical tool, allows scientists to study the composition of distant stars and galaxies, and it plays an essential role in auroral research. By examining the light emitted during auroras, researchers can infer the types and concentrations of atmospheric gases being excited. The various colors we see are not just beautiful phenomena. They provide valuable insights into the conditions prevailing in the upper atmosphere. Consider the way light travels through the atmosphere. As it moves, it interacts with particles and gases, scattering and refracting, shaping the colors we perceive. Spectroscopy captures these subtle changes, transforming light into data that can reveal the secrets of the auroras. When scientists analyze the spectrum of the auroral light, they can identify not only the presence of oxygen and nitrogen, but also trace gases like carbon dioxide and even rare elements. This interplay between light and matter has been explored by many outstanding individuals throughout history. One such pioneer, Joseph von Fraunhofer, advanced the field of spectroscopy in the early 19th century. He discovered dark lines in the spectrum of sunlight, now known as Fraunhofer lines, which correspond to the absorption of specific wavelengths by various elements in the sun's atmosphere. His work laid the groundwork for understanding how light can be used to identify the chemical makeup of celestial bodies, including the very gases that contribute to the auroras we admire today. As we reflect on the majesty of the auroras, it is intriguing to ponder how these lights have inspired scientific inquiry and artistic expression alike. The very colors that inspire awe carry within them stories of atomic interactions and cosmic phenomena. They are whispers from the universe, revealing insights about our atmosphere and the energetic processes that shape it. A question arises: how does this intricate process of light emission relate to our daily lives? The atmosphere we breathe is not merely a backdrop for the auroras. It is an active participant in the interactions that produce them. Each breath we take is rich with the very gases that create the light displays above us. Understanding these relationships deepens our appreciation for the air around us, transforming it from an invisible necessity into a vibrant part of our existence. As we delve into photonic emissions, we might also consider the role of altitude in the beauty of the auroras. The location of the emissions in the atmosphere significantly influences the colors we see. At heights of about 20 to 100 kilometers, the collisions of solar particles with oxygen produce that vivid green light. Higher up, where the atmosphere thins and energy levels are even greater, we encounter the rarer red or purple hues, often attributed to nitrogen. This layering of colors forms a stunning visual hierarchy in the sky, akin to nature's own palette, carefully arranged by the forces of physics. The ongoing research into auroral phenomena and spectroscopy continues to unveil the mysteries of our atmosphere. Scientists have developed sophisticated tools to observe and measure these light emissions, including satellite systems that capture the auroras in real time. These systems allow researchers to monitor solar activity and its impact on Earth's magnetic field, providing critical data that enhances our understanding of space weather and its effects on technology. With each new discovery, we find ourselves drawn deeper into the wonders of the cosmos. The auroras, once simply a source of wonder, are now seen through the lens of science, revealing their complexities and the interconnectedness of the universe. The vibrant displays are not only beautiful, but are also a reminder of the intricate web of energy that sustains life on Earth. As we take a moment to breathe in the significance of these connections, we can appreciate the beauty of light emissions not just as a visual spectacle, but as a scientific marvel. The colors dancing in the sky are the result of countless interactions, each with its unique story, echoing through the atmosphere and inviting us to explore the mysteries of our world. Imagine witnessing an aurora on a clear night, the sky alive with colors that shimmer and flow. Each hue tells a story of energy, of particles colliding, and of gases responding to the gentle touch of solar winds. This is the science of light emission, a delicate interplay of physics that transforms the night into a gallery of cosmic art. The fascination with auroras lies not only in their beauty, but also in the science that underpins them. The light we see is a manifestation of the complex interactions between solar particles and the atmosphere, a reminder of the dynamic forces at play in our universe. As we marvel at these celestial displays, we are reminded of the intricate relationships that sustain life and inspire inquiry, bridging the gap between science and art, between the known and the unknown. As we continue to explore the science of light emission, let us remain open to the awe and wonder that these phenomena evoke. The auroras are not merely a natural occurrence. They are a testament to the beauty of our universe, inviting us to look up and ponder the mysteries that lie beyond. The vivid spectacle of the auroras provides a remarkable opportunity to delve deeper into the dynamics of light emissions and the fascinating science of spectroscopy. As light from the auroras filters through the atmosphere, it not only dazzles the eye, but also reveals the intricate interactions between solar energy and atmospheric gases. The very act of observing these light displays allows scientists to glean invaluable information about the conditions high above the Earth's surface. Spectroscopy, the study of the interaction between light and matter, serves as a vital tool in this exploration. By analyzing the light emitted during auroras, researchers can determine the composition of the atmosphere at various altitudes. Each gas, when energized, produces a unique spectral signature, allowing scientists to identify not only the dominant gases, but also trace elements that may be present in smaller quantities. This is akin to a musician tuning their instrument, listening carefully to each note to ensure it harmonizes perfectly with the others. Imagine, if you will, the colors of the aurora as a symphony of light, each hue resonating with a specific frequency. The green light, for instance, arises from oxygen molecules at lower altitudes, while the red light, a rarer occurrence, is produced at higher altitudes under conditions where energy levels are significantly elevated. This layered display of colors creates a visual representation of the varying energy levels present in the atmosphere, painting a picture that is both beautiful and scientifically rich. Spectroscopy not only aids in understanding what gases are present, but also reveals their concentrations and physical properties. These insights are crucial for comprehending the dynamics of the upper atmosphere. For example, by studying the emission lines of nitrogen, researchers can infer temperature gradients and pressure changes at different altitudes. Such knowledge not only enhances our understanding of auroras, but also contributes to broader atmospheric science, including climate studies and the impacts of human activity on atmospheric composition. Throughout history, many brilliant minds have contributed to the field of spectroscopy. One notable figure is Gustav Kirchhoff, who, in the 19th century, developed the foundational principles of spectroscopy and demonstrated how to interpret the spectral lines produced by various elements. Kirchhoff's work illuminated the path for future scientists, enabling them to decode the mysteries of light emissions from celestial bodies. His eloquent assertion that the spectrum is a mirror of the universe captures the essence of how light can reveal the underlying fabric of existence. As we continue our exploration of the atmospheric phenomena that give rise to auroras, it is essential to consider the role of energy transfer in the process of light emission. When solar particles collide with atmospheric gases, they do more than just excite electrons. They initiate a cascade of energy transformations. This process can be likened to a game of cosmic billiards, where each collision sends ripples through the atmosphere, creating a chain reaction that results in bursts of light. This energy transfer plays a pivotal role in determining the colors and intensity of the auroras. The variations in energy levels not only dictate the colors emitted, but also influence the scale and duration of the displays. High-energy collisions may lead to more vibrant, intense colors, while lower-energy interactions result in softer, more subdued hues. This delicate balance of energy dynamics creates the ever-changing spectacle of the auroras, a reminder of the fluidity of nature's processes. Consider also the impact of atmospheric conditions on the visibility and characteristics of auroras. Factors such as temperature, humidity, and the presence of particulates can alter the way light is scattered and refracted. On particularly clear nights, when the atmosphere is calm and free of pollution, the colors of the aurora can appear more vibrant and distinct, as if nature itself has brushed a fresh coat of paint across the sky. Conversely, during periods of turbulence, the colors may blend and swirl, creating an ethereal display that feels almost otherworldly. The interplay between atmospheric conditions and light emissions highlights the complexity of the auroras, transforming them from mere visual phenomena into a rich tapestry of scientific inquiry. This complexity invites us to ponder not only what we see, but also the myriad processes that lie beneath the surface of the spectacle. As we immerse ourselves in this world of light and color, it is essential to appreciate the role of technology in enhancing our understanding of these phenomena. Modern advancements in spectroscopy, including high-resolution spectrometers and satellite-based observation systems, allow scientists to capture and analyze auroral emissions with unprecedented detail. These technologies have revolutionized our ability to monitor solar activity and its effects on Earth's atmosphere, providing real-time data that can inform both scientific research and public awareness. The journey of light from the auroras to our eyes is not merely a passive observation. It is an active engagement with the forces of nature. Every flicker and shimmer in the sky invites questions and curiosity, urging us to explore the relationships that govern our universe. In this sense, the auroras become more than just a beautiful display. They embody the rich interplay of energy, matter, and the laws of physics that shape our existence. As we look up at the night sky, painted with the colors of the aurora, we are reminded of the vastness of our universe and the intricate systems that govern it. The light we see is a testament to the beauty of science and the endless possibilities for discovery that await us. Each observation becomes a thread in the fabric of our understanding, weaving together the realms of art and science, of wonder and inquiry. What stories might the auroras tell us if we could listen to the light? Each color, each flicker carries a message, a whisper from the cosmos, inviting us to explore further and understand more deeply the world around us. The auroras, in their ephemeral beauty, challenge us to appreciate not only their visual splendor, but also the profound scientific truths that lie beneath the shimmering surface. The journey of light emission is one of exploration and wonder, a continuous unfolding that keeps us reaching for the stars. Chapter 7: The Best Locations for Viewing Auroras. In the quiet corners of our planet, where the night sky meets the earth in a gentle embrace, lies a world that beckons to those yearning for the sublime experience of witnessing the auroras. The best locations for viewing these celestial marvels are often found in geographic regions close to the magnetic poles. Picture a map with swirling patterns of light that dance above the Arctic and Antarctic circles. Countries like Norway, Sweden, Finland, and Canada offer some of the most breathtaking vistas, each with unique characteristics that enhance the auroral experience. In Norway, the city of Tromsø stands as a beacon for aurora hunters. Nestled between majestic mountains and the sea, this location provides not only a clear view of the sky, but also a rich cultural backdrop. Imagine standing on the shores of the fjord, the icy waters reflecting the ethereal glow above, while the air is filled with the sounds of laughter and stories shared by fellow travelers. As the lights appear, they weave through the darkness, creating a tapestry of colors that reflect upon the water's surface, merging the heavens with the earth. Traveling eastward, we find the vast tundras of Finland. The town of Rovaniemi, known as the official home of Santa Claus, offers a unique blend of holiday cheer and natural wonder. Here, the auroras can be seen shimmering over snow-laden forests, casting a magical glow that transforms the landscape into a winter wonderland. Imagine the crisp air biting at your cheeks, while overhead, ribbons of green and purple swirl like folklore woven into the fabric of the night. Further north in Canada, the vast expanse of the Yukon Territory presents another prime location. In the small town of Whitehorse, the skies open up to reveal a playground for light. The remote wilderness, far from the light pollution of cities, provides an unblemished view of the night sky. With the backdrop of towering pines and the distant hum of the river, the auroras here feel almost like a personal gift from the universe. Each flicker stirs the imagination, prompting the question, what stories do these lights hold for us? Beyond geographical considerations, the seasons play an equally essential role in determining the visibility of the auroras. The winter months, particularly between late September and early April, are often heralded as the prime time for viewing these lights. The long nights and clear skies of winter create perfect conditions for auroral displays. Imagine a landscape draped in white, where the stars twinkle like diamonds, and the auroras erupt in vibrant colors against a backdrop of deep indigo. As spring approaches, the nights begin to shorten, and while the auroras can still be seen, they may become less frequent and less intense. The summer months, however, bring the midnight sun, casting a bright glow even in the darkest hours, rendering auroras nearly impossible to spot. It is during the winter solstice, when the longest night of the year occurs, that the chances of witnessing the auroras are at their peak. The universe seems to conspire to provide us with a dazzling display, as if to say, look up and marvel at your place in the cosmos. Local environmental factors also influence the visibility of auroras, and understanding these elements can enhance the experience. For example, the clarity of the atmosphere plays a crucial role. Locations with low humidity and minimal pollution offer the best chances for clear views. Imagine standing in a place where the air is so pure that each breath feels like a sip of fresh mountain spring water, invigorating your senses. The absence of artificial lights allows the natural brilliance of the auroras to unfold in all their glory. Furthermore, the terrain can shape the viewing experience. Areas with elevated viewpoints, such as hills or mountains, provide an expansive horizon, allowing for a more immersive encounter with the lights. In contrast, flat landscapes offer a different yet equally enchanting experience, where the auroras stretch across the entire sky, creating a dome of color that envelops you. The time of night is another essential consideration. The hours around midnight are often cited as the most favorable for aurora viewing, as geomagnetic activity tends to peak during this time. Imagine the stillness that envelops the world, the only sounds being the whispers of the wind and the soft crunch of snow underfoot. As the clock inches toward midnight, anticipation builds like a crescendo, each moment pregnant with the possibility of witnessing nature's grand display. Equally significant is the impact of space weather on auroral activity. Solar flares and coronal mass ejections contribute greatly to the intensity and frequency of auroras. When these solar events occur, they send a surge of charged particles toward Earth, increasing the likelihood of vivid auroras. Observing the sun's activity can guide eager skywatchers to prime viewing opportunities, turning the act of chasing the lights into a thrilling adventure. In this pursuit of the auroras, one might wonder about the stories of those who have dedicated their lives to studying these phenomena. Scientists like Dr. Patricia Lewis have devoted their careers to understanding the intricate relationship between solar activity and the auroras. Dr. Lewis, with her passion for the cosmos, once stated, "The auroras are a reminder of our connection to the universe, a bridge between the solar and terrestrial realms." Her words resonate deeply with those who seek to witness the auroras, as they remind us of the intricate web of interactions that lead to these breathtaking displays. As we consider these best locations for viewing auroras, let us not forget the profound emotional impact these experiences can have. The feeling of standing beneath a shimmering sky, overwhelmed by the beauty and majesty of the universe, transcends mere observation. It becomes a moment of connection, a reminder of our place within this vast cosmos. Each viewing location, season, and environmental factor contributes to the rich experience of witnessing the auroras. From the icy fjords of Norway to the tranquil forests of Finland and the wild expanses of Canada, each place offers a unique lens through which to view this celestial phenomenon. The anticipation builds as night falls, with the heart racing at the thought of colors erupting across the sky, a reminder that even in the darkest of nights, beauty and wonder await. The pursuit of the auroras is not solely about the locations or the season, but also about the interplay of local environmental factors that can enhance or hinder the experience. Consider the influence of weather patterns, which can significantly affect visibility. Clear, cloudless nights provide the most favorable conditions for witnessing the auroras in all their glory. Imagine standing in a serene landscape, the crisp air wrapping around you like a gentle embrace, as the vast expanse of the sky above is free from clouds, allowing the vibrant lights to unfold in spectacular fashion. Conversely, overcast skies can obscure even the most vivid displays, turning the anticipation of a night under the auroras into a quiet longing. This unpredictability makes the experience all the more precious, as those who venture out into the night know that they are at the mercy of nature's whims. The thrill of the chase becomes as much a part of the experience as the lights themselves, creating a bond between the observer and the cosmos. In the far reaches of the Arctic, where the cold is biting and the nights stretch for hours, local flora and fauna play their part in shaping the viewing experience. Imagine standing beneath a canopy of stars with the silhouettes of ancient trees framing the sky. The stillness of the forest enhances the feeling of solitude and wonder as the auroras shimmer overhead, casting reflections upon the snow. The tranquility of the surroundings, punctuated by the occasional rustle of wildlife, reminds us that we are part of a larger ecosystem, where life persists even in the harshest conditions. The geographical features of a location also shape the way in which the auroras are experienced. Valleys and mountains can create natural amphitheaters, amplifying the visual spectacle. Picture yourself in a valley, where the towering peaks rise majestically on either side, their rugged outlines softened by a gentle dusting of snow. As the auroras dance above, the feeling of being enveloped in this natural embrace deepens, making the colors seem even more vibrant against the dark sky. The proximity to bodies of water offers yet another layer of enchantment. Lakes and rivers can reflect the auroras, creating a mirrored effect that doubles the spectacle. Imagine standing on the shores of a still lake, the surface so calm that it appears like glass. The auroras ripple overhead, and for a brief moment, it feels as if you are suspended between two worlds, the one above and the one below, each filled with vibrant hues and shimmering light. Throughout history, the quest for understanding these celestial displays has captivated scientists and dreamers alike. Individuals such as Dr. John R. Schilling, a dedicated researcher in the field of atmospheric sciences, have dedicated their lives to studying the patterns and behaviors of the auroras. Dr. Schilling once remarked, "The auroras are nature's way of reminding us of the interconnectedness of our world." His explorations and findings contribute to a greater understanding of how local conditions, solar activities, and atmospheric interactions converge to create these breathtaking phenomena. As we explore the best locations for aurora viewing, we must also consider the cultural significance of these experiences. Many indigenous cultures have long understood the importance of the natural world and its cycles. The Sami people of northern Scandinavia, for instance, have a rich tradition of storytelling that weaves together their understanding of the auroras with their deep respect for the land. They view the lights not just as natural phenomena, but as a part of their spiritual heritage, a connection to their ancestors and the universe. Imagine a gathering around a fire, voices raised in song and story, as elders share tales of how the lights guide lost souls home. Such traditions remind us that the experience of witnessing auroras transcends mere observation. It is a moment steeped in history and meaning, connecting us to the wisdom of those who have come before us. The experience of aurora viewing is also about community. Travelers from around the globe come together, united by a common goal, to witness the magic of the lights. The camaraderie among strangers, all of whom share in the anticipation of a dazzling display, creates a sense of belonging. As they gather beneath the stars, exchanging stories and laughter, the night transforms into a tapestry of human connection, woven together by the shared wonder of the auroras. With each passing moment, the excitement builds. Will tonight be the night when the sky bursts into life? Each flicker and shimmer draws the gaze, creating a palpable energy in the air. As one stands beneath the undulating ribbons of light, there is a profound realization. We are not merely observers of this celestial ballet, but participants in a grand narrative that connects us to the cosmos. As we reflect on the best locations for viewing auroras, it becomes clear that the experience is layered with meaning, beauty, and connection. The geographical features, seasonal variations, and local environmental factors all work in harmony to enhance the spectacle. Each location offers a unique lens through which to view this incredible natural phenomenon, inviting us to embrace the mystery and wonder of the universe. In the stillness of the night, as the auroras begin to unfold, we are reminded of our place in this vast cosmos. The lights above are not just a spectacle, they are a celebration of life, energy, and the unending quest for knowledge that drives us forward. Each moment spent beneath the auroras is a whisper from the universe, urging us to look up, to marvel, and to remember that we are all part of something far greater than ourselves. Chapter 8: Myths and Legends Surrounding Auroras. Across the ages, the Aurora Borealis has inspired countless stories, myths, and legends. Cultures around the world have woven their interpretations of these dazzling lights into the fabric of their societies, enriching our understanding of both the phenomenon and the human experience. Imagine the Arctic sky aglow with shimmering colors, each hue resonating deeply with the beliefs and traditions of the people who gaze upon it. In Norse mythology, the auroras were seen as the reflections of the Valkyries, the warrior maidens who chose those who would live and die in battle. The Vikings believed that these ethereal lights guided the souls of fallen heroes to Valhalla, their heavenly abode. Picture the bold warriors, their spirits soaring amidst the vibrant displays, feeling the embrace of the Valkyries as they ascend to the afterlife. This interpretation not only illustrates the significance of the auroras in Viking culture, but also underscores a deeper connection to the cosmos, where the boundaries between life and death blur beneath the bright glow of the northern lights. In North America, indigenous peoples have their own rich narratives surrounding the auroras. The Cree, for instance, viewed these lights as the spirits of their ancestors playing a game of ball in the sky. Imagine standing under the vast expanse of the night, feeling a sense of kinship with those who have come before, their laughter echoing through the cosmos. The Sami people of Scandinavia, too, believed that the lights were the souls of their forebears, dancing in the sky to reflect their emotions and actions. Such beliefs highlight the profound respect these cultures hold for their ancestors, as well as their desire to connect with the celestial realm. Folklore often shapes how we perceive natural phenomena, and the auroras are no exception. As stories of the northern lights spread across continents, they evolved, taking on unique characteristics that mirrored the values and beliefs of each culture. For instance, in some Native American traditions, the lights were seen as a warning, a sign from the spirit world. They served as reminders to live harmoniously with nature, reinforcing the importance of balance and respect within the environment. Even in modern times, the auroras continue to evoke wonder and curiosity, influencing our artistic expressions and cultural narratives. The captivating colors and shapes inspire painters, poets, and musicians alike, each striving to capture the essence of this cosmic spectacle. Imagine the brush strokes that mimic the flowing waves of green and purple, or the melodies that echo the gentle movements of the lights across the night sky. These creative interpretations keep the spirit of the auroras alive, bridging the gap between science and art. As scientific understanding of the auroras has advanced, our perceptions have also shifted. While once viewed solely through the lens of mythology, we now appreciate the intricate interplay of solar particles, Earth's magnetic field, and atmospheric gases that create this stunning display. Yet, even with this knowledge, there remains an element of mystery. The beauty of the auroras transcends mere explanation. They invite us to ponder our place in the universe, to reflect on our connections to the past, and to find solace in the vastness of the night. In some cultures, the auroras are seen as omens. The Inuit, for example, believed that the lights were the spirits of the dead, and their appearance could foretell significant events. Imagine the elders gathering to interpret the movements in the sky, their wisdom passed down through generations. These interpretations serve not only to guide actions, but also to foster a sense of community, as people come together to seek meaning from the celestial phenomena. As we explore different societies' interpretations of the auroras, it becomes evident that these stories are more than mere folklore. They are reflections of the human experience. They reveal our innate desire to find meaning in the world around us, to seek connections with the forces that shape our existence. The auroras, in their magnificent displays, remind us of our shared humanity, transcending geographical boundaries and cultural differences. In a world where scientific explanations often dominate our understanding of nature, folklore offers a complementary perspective. It enriches our appreciation of the auroras by inviting us to see them not just as an atmospheric phenomenon, but as symbols of hope, connections to the past, and expressions of our deepest emotions. The stories we tell about the lights can inspire future generations to carry forth the legacy of wonder and reverence for this magnificent spectacle. In recent years, modern technology has allowed us to capture the auroras in stunning detail, bringing their beauty into our homes and daily lives. Social media platforms are flooded with breathtaking images and videos, allowing people from all corners of the globe to experience the magic of the Northern Lights. However, as we gaze upon these digital representations, we must remember the stories and beliefs that have shaped our understanding of these lights throughout history. The auroras are a testament to the interplay between science and mythology, a reminder that both perspectives can coexist harmoniously. Just as the scientific community seeks to understand the mechanisms behind the auroras, the stories passed down through generations continue to inspire awe and wonder. Imagine being enveloped in the soft glow of the lights, feeling the weight of history and culture surrounding you as you bask in the beauty of the moment. As we reflect on the myths and legends surrounding the auroras, we find that they offer us a lens through which to view our own lives. The lights serve as a metaphor for the connections we share with one another and the universe. They remind us that, like the colors that illuminate the sky, our stories, traditions, and beliefs shape our understanding of the world. Each culture's interpretation adds depth to the narrative of the auroras, creating a rich mosaic of human experience. In the end, the auroras are not just a natural phenomenon. They are a bridge between the past and the present. They inspire us to look up at the night sky and ponder the mysteries that lie beyond our understanding, while also connecting us to the generations that have come before us. As we continue to share stories of the auroras, we honor the wisdom of those who have gazed upon these lights, reminding us that we are all part of a much larger cosmic story. As we explore the rich tapestry of myths and legends surrounding the auroras, we uncover a myriad of cultural interpretations that reflect the values and beliefs of diverse societies. In Japan, for instance, the auroras are often associated with the gods and celestial beings. The Ainu people, the indigenous inhabitants of Hokkaido, believed that the lights were the manifestations of the spirits of the dead, illuminating the path to the afterlife. This belief encapsulates the reverence the Ainu hold for nature and the cosmos, as they view the auroras not merely as a spectacle, but as a spiritual guide. Envision the serene landscapes of Hokkaido, where the sky ignites with vibrant hues, each flicker a reminder of the connection between this world and the next. In the Arctic regions, the Sami people have their own interpretations, where the auroras are thought to be the spirits of their ancestors dancing across the sky. The Sami have long celebrated the beauty of these lights, creating songs and stories that resonate with their deep respect for nature and its mysteries. They often refer to the auroras as the lights of the dead, a phrase that carries both reverence and a sense of continuity between generations. Imagine standing in the snowy expanse of Lapland, the air crisp and alive with the whispers of the past, as the auroras swirl above, weaving a narrative that connects the living and the departed. In many Native American cultures, the auroras have been viewed through a lens of caution and respect. The Ojibwe, for example, regarded the lights as a sign from the spirit world. They believed the auroras were the souls of deceased ancestors, and their appearance in the sky could indicate that it was time for the living to reflect on their actions and relationships. This perspective highlights a recognition of the interconnectedness of all beings, urging individuals to honor their past while remaining attuned to the rhythms of the natural world. Picture a gathering of families under a starlit sky, their hearts beating in sync with the flickering lights as they share stories and lessons passed down through generations. The legends of the auroras extend beyond specific cultures, influencing the collective imagination of humanity. They serve as a reminder of our shared curiosity and the innate desire to seek meaning in the natural world. As scientific knowledge has expanded, we have begun to understand the intricate processes behind these luminous displays. Yet, the myths persist, adding layers of richness to our experience. How often do we find ourselves captivated by a sunset or a starry night? And in that moment, do we not feel a connection to those who have gazed upon the same sky before us? The interplay between science and folklore invites us to consider the ways in which our understanding of the auroras has transformed over time. While we now comprehend the physical phenomena behind the lights, charged particles colliding with atmospheric gases, the stories we tell about them continue to shape our perceptions. As Albert Einstein once said, "Imagination is more important than knowledge." This sentiment resonates deeply in the context of the auroras. The myths and legends enrich our appreciation of the phenomenon, inviting us to dream and wonder even as we seek factual understanding. In contemporary society, the auroras have not only inspired art and literature, but have also become symbols of hope and resilience. Artists and writers draw upon the ethereal beauty of the lights to express themes of transformation and connection. Imagine a canvas splashed with vibrant greens and purples, each stroke echoing the movement of the auroras across the sky. Such artistic expressions serve as a bridge, linking the scientific and the spiritual, the past and the present. As we navigate the modern world, technology has provided us with unprecedented access to the auroras. High-resolution images and videos shared across digital platforms allow people from all walks of life to witness the beauty of the northern lights. But do these representations capture the essence of the experience? The glow of a screen cannot replicate the sensation of standing beneath the auroras, feeling the chill of the night air and the exhilaration of witnessing nature's grandeur. Yet, this accessibility fosters a sense of global community, uniting individuals in their shared awe of the cosmos. With this technological evolution comes a challenge. How do we preserve the cultural narratives that have long surrounded the auroras? These myths, deeply rooted in human history, carry valuable lessons and insights that transcend mere entertainment. They remind us of our connection to the earth and to one another. In a world increasingly dominated by scientific rationality, how can we ensure that these stories are passed on to future generations? Perhaps the answer lies in embracing both perspectives, the scientific and the mythological. The auroras, as awe-inspiring as they are scientifically, also serve as a powerful reminder of the human experience. Each story we tell adds depth to our understanding, offering context to the beauty we witness. When we gaze upon the northern lights, we are not simply observing a natural phenomenon. We are participating in a timeless dialogue between humanity and the universe. As we continue to explore the myths and legends surrounding the auroras, it becomes clear that these stories are not just relics of the past. They are living narratives that shape our present and guide our future. They beckon us to look beyond the colors that dance in the sky, inviting us to reflect on the profound connections that bind us to each other and to the cosmos. In this interplay of light and shadow, we find not only beauty, but also a deeper understanding of our place in the universe. The auroras remain a powerful testament to the intersection of science and mythology, a reminder that the mysteries of the universe can inspire both knowledge and wonder. As we share these stories, We honor the traditions of those who have come before us, each narrative illuminating the path forward as we continue to seek meaning in the celestial displays that grace our skies. Chapter 9: The Impact of Climate Change on Auroras. As we explore the impact of climate change on auroras, we find ourselves standing at the intersection of our warming planet and the cosmic ballet of solar activity. Climate change, a phenomenon reshaping our world, holds the potential to alter not just our environment, but also the dazzling displays of light that grace our skies. It is a complex relationship, where the warming atmosphere and changing solar dynamics intertwine, creating a narrative that is as breathtaking as it is concerning. Imagine the sun, a steadfast source of energy, sending forth its charged particles, which journey through the vastness of space to interact with Earth's magnetic field and atmosphere. Yet, as our climate shifts, so too does the behavior of the sun. While the solar cycle, a roughly 11-year cycle of solar activity, continues its rhythm, scientists observe that the effects of climate change may influence this cycle in subtle yet significant ways. What if higher global temperatures could alter solar activity patterns, potentially changing the frequency and intensity of auroras? As we ponder this possibility, it becomes clear that the composition of our atmosphere is also undergoing transformation. The rise in greenhouse gases, particularly carbon dioxide, not only contributes to global warming, but can also impact the delicate balance of gases that play a crucial role in auroral displays. A thickening blanket of these gases could absorb more energy from the sun, altering how that energy interacts with atmospheric particles. Picture a canvas splashed with colors, where the hues begin to shift as the palette changes. This is akin to what we may observe in the auroras as our atmosphere evolves. The atmospheric gases, primarily nitrogen and oxygen, are essential players in the creation of auroras. With increased levels of pollutants and altered atmospheric composition, the delicate interactions that produce the vibrant colors of the aurora borealis could be at risk. Would we witness fewer displays of the brilliant greens and reds that have mesmerized generations? The thought invites a moment of reflection as we consider the potential loss of this natural wonder. As we delve deeper into the effects of climate change, we must also reflect on the future of auroral visibility. With changes in global weather patterns, the regions that currently enjoy the best views of these celestial phenomena may experience shifts in their accessibility. Imagine standing in the pristine areas of the Arctic, where the cold, clear nights offer unobstructed views of the auroras. Yet, as the climate warms, these regions may face unpredictable weather, cloud cover, and even changes in habitat that could affect the very ecosystems that support auroral viewing tourism. Notably, researchers have begun to study these changes closely, seeking to understand how climate change may impact the auroras over time. What changes might we see in the frequency of these displays? Will the stunning colors continue to light up our skies, or will they fade into the annals of history? The answers to these questions are yet to be fully understood, but the implications are profound. The connection between solar activity and the Earth's climate is a dynamic and evolving topic. Some scientists propose that periods of increased solar activity could coincide with shifts in climate, but these relationships are intricate and complex. As we witness the sun's behavior, we must also consider the delicate balance of Earth systems. Could it be that the very activities we engage in to combat climate change may also impact our view of the auroras? As we reflect on the future, it is essential to consider the voices of those dedicated to understanding these cosmic phenomena. Scientists and researchers are piecing together the puzzle, striving to understand how our changing planet impacts the majestic auroras. One such voice, a noted expert in the field, once said, "The truth is out there. waiting to be discovered. This quest for knowledge is a reminder of our responsibility to both the planet and the universe. In a warming world, where the delicate interplay between solar activity and atmospheric conditions continues to evolve, our ability to witness the auroras hangs in the balance. The sight of these natural wonders has inspired countless generations, igniting a sense of curiosity and wonder. As we stand on the precipice of change, we are called to cherish these moments, to protect the environment that allows such beauty to flourish. Imagine the skies, painted with the shimmering hues of the aurora, each wave of color telling a story of the sun's energy and the Earth's atmosphere. Will we continue to have the opportunity to witness such breathtaking displays, or will the impacts of climate change alter our relationship with this celestial phenomenon? The future remains uncertain, but our collective actions today can influence the legacy we leave for tomorrow. As we ponder the fate of the auroras in a changing climate, let us also consider the rich stories that surround these lights. They have long been a source of inspiration for poets, artists, and scientists alike. In the face of potential change, these stories remind us of the beauty that exists in our world and the importance of preserving it. The auroras have captivated humanity for centuries, and their glow serves as a beacon of hope and wonder against the backdrop of our universe. The interplay of solar winds and Earth's atmosphere has created a spectacle that transcends time, cultures, and borders. It invites us to reflect not only on the science behind the auroras, but also on the profound connections we share with our planet and the cosmos. In a warming world, the future of these celestial displays is worth contemplating deeply, as it intertwines with our understanding of climate change and its broader implications. As we gaze upward at the night sky, we are reminded of our place in the vast universe. The auroras are not merely a breathtaking phenomenon, they signify the intricate relationship between our Earth and the Sun. As we continue to explore this relationship, let us remain vigilant, ensuring that the lights of the Aurora Borealis continue to inspire generations to come, illuminating our nights with their enchanting glow. As we consider the potential changes in atmospheric composition due to climate change, it is essential to understand how these changes might influence not only the auroras themselves, but also the conditions that allow us to witness this spectacle. The Earth's atmosphere is a delicate balance of gases, each playing a critical role in both sustaining life and interacting with the solar winds that create the auroras. Imagine a vibrant, living tapestry, where each thread represents a different gas, nitrogen, oxygen, and trace elements, all contributing to the overall picture. In a warming world, the increased concentration of greenhouse gases may lead to alterations in this delicate balance. Higher levels of carbon dioxide and other pollutants could create a thicker, more opaque layer, effectively filtering and absorbing the very energy that fuels the auroras. Would this mean that the stunning displays we have come to cherish might be dimmed, muted by our own actions? The potential impact on the visibility of auroras stretches beyond atmospheric composition. As global temperatures rise, the patterns of weather and climate are shifting, creating new challenges for those who seek to experience these celestial wonders. For example, the Arctic regions, traditionally considered optimal viewing sites, may face unpredictable weather conditions, including increased cloud cover and storms. Imagine standing in a remote, cold expanse, eagerly awaiting the lights to dance across the sky, only to be met by clouds that obscure your view. This unpredictability raises important questions. How will the patterns of auroral displays change in a warmer world? Will the frequency of these breathtaking occurrences diminish, or will they become confined to different geographical regions? Researchers are actively investigating these possibilities, drawing on data from past solar cycles and current climate models. they hope to create a clearer picture of how auroras may evolve as our planet continues to warm. As we delve into the stories of those who have dedicated their lives to studying these phenomena, we come across figures like Dr. R. Andrew P. Hargreaves, a renowned physicist who has made significant contributions to our understanding of the interactions between solar activity and Earth's atmosphere. He once stated, "The auroras are a direct reflection of the sun's influence on our planet, a connection that reminds us of how interconnected we truly are." His insights highlight the importance of understanding the sun's behavior and its potential to influence not just the natural world, but also our experiences of awe and wonder. The challenges brought on by climate change do not merely threaten the visibility of auroras, they also pose risks to the ecosystems that thrive in the Arctic regions. Many species rely on stable environments to survive, and as weather patterns shift, their habitats may be disrupted. Imagine the ripple effect that could ensue, where changes in animal migration patterns or plant blooming seasons lead to broader ecological consequences. The delicate interplay between climate, environment, and the auroras serves as a reminder of the intricate web of life that connects us all. As we ponder the future of auroras, it is essential to consider the role of awareness and action. The capacity to witness these breathtaking displays is a privilege that many cherish, evoking a sense of connection to the cosmos and our planet. In this age of climate change, we are called not only to appreciate the beauty of the auroras, but also to protect the environment that allows them to flourish. Imagine a world where the lights of the Aurora Borealis continue to shimmer across the sky, a testament to our efforts to combat climate change and nurture our planet. Each time we gaze upward and witness the vibrant colors dancing above, we are reminded of our responsibility to ourselves, to future generations, and to the myriad forms of life that call Earth home. As we stand at the precipice of change, the stories of the Aurora Borealis remind us of the beauty that exists in our world and the importance of preserving it for those who will come after us. The challenges we face are daunting, yet they also provide an opportunity to innovate, to adapt, and to work together toward a brighter future. In the stillness of a wintry night, as the first hints of color begin to emerge on the horizon, one can only hope that the future holds many more breathtaking displays of the Aurora Borealis. This natural wonder, a gift of the cosmos, represents not just the beauty of our planet, but also the resilience of our spirit in the face of challenges. It invites us to dream of a world where the lights continue to inspire, to awe, and to connect us with one another and the universe we inhabit. As we turn our gaze to the potential changes in atmospheric composition, we find ourselves contemplating the intricate web of interactions that define our environment. The atmosphere, a dynamic system, is constantly influenced by various factors, including human activity. The increase in greenhouse gases, particularly carbon dioxide and methane, alters the delicate balance that sustains life on Earth. Imagine this transformation as a gentle tide, reshaping the landscape of our sky and, in turn, the auroras that illuminate it. The presence of pollutants, such as aerosols and particulate matter, can also significantly affect the way sunlight interacts with the atmosphere. These particles can scatter and absorb light, resulting in a muted palette of colors during auroral displays. Picture a vibrant painting, where the original hues are dulled by a layer of gray, a reflection of how our actions impact the beauty of the natural world. The potential for a less vivid aurora raises a poignant question. Are we prepared to witness a future where the brilliance of the northern lights becomes a memory rather than a reality? The changing composition of the atmosphere may also influence the altitude at which auroras typically occur. As atmospheric density adjusts, the dynamics of how charged solar particles collide with atmospheric gases will evolve. Imagine these particles becoming explorers, navigating through a landscape that is no longer familiar. The height at which they engage with nitrogen and oxygen could shift, potentially leading to new color displays or altered patterns in the auroras. The uncertainty surrounding these changes invites us to reflect on our role in shaping this future. Moreover, the relationship between climate change and the solar cycle is a topic of growing interest among scientists. With the sun's activity waxing and waning in an 11-year cycle, we must consider how a warming atmosphere could influence solar phenomena. Could the effects of climate change cause the solar cycle to manifest differently? Some researchers suggest that the interactions between the sun's magnetic field and Earth's atmosphere could lead to unexpected consequences, perhaps even altering the frequency of auroral displays. The intricate dance between our planet and the sun is a reminder of the delicate balance upon which these breathtaking displays depend. As we ponder the future of auroral visibility in this warming world, we cannot overlook the impact of shifting geographical patterns. The regions that currently boast the best views of the auroras may not remain unchanged. Areas once cloaked in darkness may become less accessible due to climate-induced changes, including increased cloud cover and altered weather patterns. Imagine the thrill of chasing the auroras, only to find that the once reliable conditions have transformed into a capricious landscape. How will this affect the communities that rely on auroral tourism? And what stories will be lost if fewer people have the opportunity to witness these celestial wonders? Scientists are diligently working to understand these potential shifts, relying on observations and data to paint a clearer picture of the future. The role of citizen scientists has become increasingly important in this endeavor. Enthusiasts who capture auroras through photography or share their observations contribute valuable information to a growing body of research. Each snapshot taken in the stillness of a winter night serves as a testament to the relationship between humanity and nature, as well as the shared responsibility we hold in safeguarding our planet. Among the voices advocating for this understanding is Dr. Jennifer L. Fennell, an astrophysicist who emphasizes the importance of public engagement in scientific research. She once said, "Science is not just for scientists, it is a collective journey. Every observation counts." Dr. Fennell's words echo the sentiment that our connection to the auroras is not merely one of observation, but of participation in a broader narrative that intertwines science, art, and culture. As we reflect on the potential futures of auroras in a changing climate, we are reminded of the stories they tell. Each flicker of light is a whisper from the cosmos, an invitation to explore the mysteries of our universe. The auroras hold a mirror to our own existence, reminding us of the interdependence that links humanity, the environment, and the celestial wonders above. In this moment of contemplation, let us envision a world where the auroras continue to grace our skies, untainted by the shadows of climate change. Each stunning display serves as a reminder of our potential for resilience and adaptation. The vibrant colors of the Aurora Borealis can continue to inspire, urging us to take action in preserving the delicate balance of our planet. As we look toward the horizon, may we remain vigilant stewards of the Earth, ensuring that the lights above remain a source of wonder for generations to come. Chapter 10: Capturing the Aurora Borealis Photography Tips. As the northern lights begin to dance across the sky, many dream of capturing this ethereal beauty through the lens of a camera. Photographing the Aurora Borealis is an endeavor that requires both preparation and an appreciation for the delicate interplay between light and atmosphere. To create striking images of the aurora, one must embrace certain best practices. First and foremost, finding the right location is crucial. Seek out areas with minimal light pollution, where the stars can shine brightly against the dark canvas of the night. Imagine standing on a remote hilltop, the air crisp and invigorating, as the sky begins to shimmer with vibrant colors. This vantage point not only enhances the visibility of the aurora, but also allows the photographer to incorporate the landscape into their images. Consider framing the aurora against a backdrop of mountains or trees, adding depth and context to the scene. Timing is another essential factor. The best displays of the aurora often occur during the winter months when the nights are long and dark. The cold air can feel biting, yet it also brings clarity to the atmosphere, allowing the colors to reveal their full brilliance. Imagine wrapping yourself in warm layers, the satisfying crunch of snow beneath your feet, as you await the moment when the sky ignites with light. Once the location and timing are established, the next step involves selecting the right equipment. A sturdy tripod is non-negotiable, providing stability for long exposure shots that capture the essence of the aurora. The camera should be capable of manual settings, allowing the photographer to manipulate the aperture, shutter speed, and ISO to achieve optimal results. A wide-angle lens can be particularly advantageous, enabling one to capture the vastness of the sky and the intricate details of the aurora's movements. As you prepare your camera, consider the settings that will best capture the aurora's dance. A higher ISO can help pick up the faintest lights, while a wide aperture allows for more light to enter, essential in low-light conditions. Imagine adjusting your camera, the soft click of buttons echoing in the stillness of the night, as you find the perfect balance to immortalize the moment. Experimenting with shutter speeds is key. Longer exposures can create a dreamy effect, blurring the lights into sweeping ribbons of color. A good rule of thumb is to start with a shutter speed of several seconds, gradually adjusting based on the intensity of the aurora. As you shoot, it's important to take test images, allowing for adjustments in real time. With each click, you capture the essence of the aurora, preserving its fleeting beauty for years to come. While the technical aspects of photography are important, the emotional connection to the experience cannot be overlooked. Each moment spent under the aurora is an invitation to breathe deeply, to reflect on the wonders of the universe. As you watch the lights flicker and shimmer, consider the stories they tell, the ancient myths and scientific marvels that blend seamlessly in the sky above. Remember the words of an influential photographer: "You don't take a photograph, you make it." Each image becomes a personal interpretation of your experience, a testament to the bond between artist and nature. Planning an aurora photography trip involves more than just identifying a location and gathering equipment. It's about immersing oneself in the journey, understanding the nuances of the environment, and anticipating the whims of nature. Researching aurora forecasts can provide insight into when conditions are optimal for viewing, as the interplay of solar activity and atmospheric conditions can greatly influence the likelihood of sightings. Imagine checking your preferred aurora forecast website, the excitement building as predictions align with your travel plans. Moreover, consider the logistics of your trip. Traveling to remote locations may require careful planning, from accommodations to transportation. Picture yourself driving through snow-dusted landscapes, each mile bringing you closer to the anticipated spectacle. Arriving at your destination well before nightfall allows for exploratory walks to familiarize yourself with the surroundings and scout ideal photography spots. Joining a guided tour can also enhance your experience, as knowledgeable guides often possess a wealth of information about local conditions and the best viewing angles. They may share insights into the science behind the auroras, enriching your understanding while also providing camaraderie with fellow enthusiasts. Imagine sharing stories and laughter around a warm fire, the anticipation of the night ahead filling the air with excitement. When the evening arrives, patience becomes your ally. The aurora can be unpredictable, sometimes manifesting in brief flashes before fading into the night. It is essential to stay alert and engaged, watching for the signs of activity in the sky. As you await the arrival of the lights, consider the vastness of the universe and the intricate dance of particles that leads to this moment. Each flicker of light is a reminder of the powerful forces at play, a connection to the cosmos that is both humbling and awe-inspiring. In the quiet moments of anticipation, take the time to enjoy the serenity of the night. The air is filled with a stillness that invites contemplation, allowing thoughts to drift like the clouds above. Imagine the sensation of peace enveloping you as the night sky stretches endlessly, a canvas awaiting its colors. When the aurora finally appears, allow yourself to be swept away by its beauty. Each burst of color is a fleeting moment, a reminder of nature's impermanence. Capture these moments with intention, breathing in the wonder, and letting the experience wash over you. The clicks of your camera become a symphony, each sound punctuating the silence of the night, a celebration of the extraordinary. As you return home from your journey, the photographs you take will serve as portals to those magical nights beneath the auroras. Each image will encapsulate not just the colors that painted the sky, but the emotions, the stories, and the connections forged under the celestial display. Remember that capturing the aurora is not merely about the technicalities of photography. It is about embracing the experience, allowing the magic of the moment to resonate within you. The northern lights, with their mesmerizing beauty, beckon those who wish to witness and capture their splendor. The journey of photographing the aurora is an invitation to explore, to connect, and to celebrate the wonders of our universe. Embrace the adventure, for it is a journey that promises not only stunning images, but also memories that will last a lifetime. As the anticipation of capturing the northern lights builds, it becomes essential to consider the finer details that can enhance your photography experience. One such detail is the importance of composition. Just as a painter chooses their colors and forms with care, a photographer must thoughtfully arrange elements within the frame. Imagine the contrast of the vibrant aurora against the silhouette of a lone tree, or the reflection of lights shimmering on a still lake. These compositional choices not only tell a story, but also evoke emotion, inviting viewers into the scene. Utilizing leading lines can guide the viewer's eye toward the aurora, enhancing the sense of depth and perspective. Roads, rivers, or the contours of the landscape can serve as natural guides that draw attention to the sky above. As you frame your shot, consider how these elements interact with the aurora, creating a harmonious balance that captivates the senses. The words of a renowned photographer resonate here. Composition is the strongest way of seeing. This idea reinforces the notion that the arrangement of visual elements is just as critical as the phenomenon itself. Once you've established your composition, consider the impact of post-processing on your images. While capturing the lights is vital, the journey doesn't end with the camera shutter. Post-processing allows you to fine-tune your photos, enhancing colors, contrast, and sharpness to reflect the awe-inspiring experience you witnessed. Imagine sitting in a cozy nook at home, sipping a warm drink while you revisit the images from your adventure. Through careful editing, the colors of the aurora can be brought to life, making them pop in a way that mirrors the emotional intensity of your memories. Moreover, consider the atmosphere around you while photographing the auroras. The experience is as much about the sights as it is about the sounds and sensations of the night. The crunch of snow underfoot, the crispness of the air, and the stillness surrounding you all contribute to the overall ambience. Allow these sensory details to seep into your work as they form the backdrop to the visual narrative you are creating. There is a profound connection between the environment and the photographs you take, each enriching the other. Planning ahead also involves informing yourself about the local wildlife, which can add layers to your photographic journey. Imagine the thrill of spotting a herd of reindeer silhouetted against the aurora-lit sky, or the quiet grace of an owl perched nearby, observing the spectacle above. These encounters not only enrich your experience, but can also provide unique compositions that highlight the connection between the natural world and the wonders above. Additionally, consider the importance of flexibility in your plans. The aurora can be elusive, sometimes requiring you to adapt to its whims. Being open to changing your location or waiting a little longer can yield unexpected rewards. Perhaps the clouds will part just in time to reveal a stunning display, or the lights may shift in ways you hadn't anticipated. Each moment spent waiting can be an opportunity for reflection, enhancing your appreciation for the beauty of the night sky. Engaging with the local culture can also enrich your photography experience. Many regions known for aurora sightings offer cultural insights that deepen your understanding of this natural phenomenon. Local guides may share their stories, folklore, and perspectives of the aurora, providing context that can resonate within your photographs. Imagine discussing the significance of the lights with a local elder, their eyes sparkling with memories as they recount tales that have been passed down through generations. This connection to the land and its people can infuse your work with a sense of place, making your photographs not just images, but narratives that honor both the natural and cultural heritage. As you prepare for your aurora photography adventure, remember to bring along a notebook or journal. Documenting your thoughts, feelings, and experiences can serve as a resource for reflection and creativity later. Imagine penning down the emotions that wash over you while standing beneath a swirling display of light, capturing the essence of the moment in words that can accompany your images. This practice of merging photography with writing can deepen your connection to the experience, providing a multifaceted approach to storytelling. In addition to these considerations, it's vital to remember the ethics of photographing nature. Strive to minimize your impact on the environment and respect local wildlife. Enjoy the beauty of the aurora without disturbing the delicate ecosystems that thrive in those regions. By embodying a spirit of stewardship, you contribute to the preservation of these breathtaking landscapes for future generations to marvel at. As you prepare to embark on your journey to capture the northern lights, take a moment to breathe in the excitement and wonder of what lies ahead. The auroras are more than just a visual spectacle. They are a reminder of the intricate forces that shape our world and the connections we forge with nature. Each photograph is an opportunity to share this beauty with others, inviting them to experience the magic of the aurora through your eyes. The adventure of photographing the northern lights is not solely about the images you create, but also the stories you gather along the way. Whether it's the moments spent in solitude beneath the stars or the friendships formed with fellow travelers, each experience enriches your understanding of the universe and your place within it. As your journey unfolds, let the allure of the aurora guide you, illuminating not just the night sky, but also the path of discovery and connection that lies ahead.